There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
'21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. '21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
'21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the '21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge.
Good morning, everyone. So we are back on our third day of the Virtual Developers Conference, and we have a great day ahead of us. And actually, I'll be your first speaker. And upcoming sessions today are going to be about containers. We have some machine learning, and 2 sessions on event sourcing, Kubernetes, and CI and CD. Hope you will be sticking with us throughout the day. Good morning, Stej. How's it going?
Thank you, Neil. How are you? Are you ready for your presentation?
Oh, yeah, sure.
So, Neil, everybody who has been our host since day one, since Wednesday, is going to have his presentation today. And he is proudly representing Event Store. Ooh.
Yes, thank you. Actually, we have 3 event store sessions today, so really looking forward to that.
Awesome. In Avengers Tower itself, or
Yes, in Avengers Tower itself.
in Avengers Tower? Oh, yes, great. Whenever you're ready, Neil, we can proceed. It's weird to host you.
Okay, sure, let's get started. Hello, I'm Neil. I'm a DevOps engineer at Event Store, and today I'll be talking about modern infrastructure as code with Pulumi. Let's jump right into it. So, when you're running your applications in the cloud, there are various aspects of the infrastructure that you need to take care of, like your images, maybe container images, you're doing that, your virtual machines, databases, and security. And especially nowadays where our application architecture is more service driven rather than having a single monolithic thing. This becomes hard to manage as our application scales, and infrastructure as code is a reliable way to describe our infrastructure and the state we want it to be using code, and make those infrastructure deployment easily repeatable. So Pulumi is an open source solution for infrastructure as code and allows us to describe infrastructure in programming languages. Traditionally, for example, if we take CloudFormation from AWS, it allows us to describe infrastructure in JSON. Another example would be Terraform, which uses a domain-specific language. Comparing that to Pulumi, where you can use real programming languages, you can take advantage of a lot of the language features, such as control flow, loops, and conditional, which you wouldn't have in JSON. And you can use abstraction and easily reuse your code and sharing your code as packages. And another thing is that you can deploy to any major cloud provider. What's on my screen is just a small subset of them right now, but you could even do Alibaba Cloud or DigitalOcean if you want. A full list of it is available on the Pulumi website. And one last thing that I will be talking about is policy as code, where you can set up security or business policies that such that if any of your infrastructure deployment infringes any of those, they are blocked. And all that done using code. And I will have a practical demo about this later in this presentation. So let's have a look actually at what demos we will have. So firstly, I will demo how to deploy a static website on Amazon S3 using JavaScript. Our next demo after that is going to be deploying an EC2 web server using C# this time. And finally, we will have a look at how to enforce policy as code on those two previous deployments. So let's jump right into the demos. So we are now inside Visual Studio Code, and I already have a Premise CLI set up with my AWS credentials. You can look up how to set up a Premise CLI for your cloud provider of choice on the Premise website. So how Premise works is that at the top you have an organization, and within an organization you can have multiple projects. So right now we're gonna create a project using the command Premise, and this will present us with a list of templates. And for a reminder, we are trying to deploy an S3 bucket website on AWS, and that written in JavaScript right now. So I will choose the AWS JavaScript template, and you have a few things to fill in, like the project names and the descriptions and the stack. So if you want to have multiple deployments of the same application, you can use stacks. Let's say you want one instance of your deployment in a particular region and another one in another region. You could use two different stacks to have two deployments of the same application. And once I hit enter, this would create a new project as well as install dependencies for the code. That takes a minute, so I've already done that to save us some time. So let's just check the code out. So what this would give us is this list of files here, and let's check out the index.js. So in this file, you can see that we have our infrastructure defined. So it starts with a set of packages, and you can see here we are constructing a bucket object. And that's how infrastructure is declared in Premise. And at the end, we are exporting the bucket ID, which will make the bucket ID available for the Premise CLI later. So if you want to make this deployment right now, I would type Premise up, and it's gonna analyze the code and figure out what we want to deploy. And we should have a preview of the deployment in a few. So here's our preview, and Premier has figured out that you want to deploy one bucket. And if we click on yes right now, it's gonna carry on and deploy our bucket to AWS. So now it's creating the bucket. And here we go, our bucket has been created, and here we have our bucket ID which has been quoted. So right now we have an empty bucket. Let's add an HTML file into it. Let's make a public folder to store our HTML files. And let's create an index.html file. So real quick, let's add some content to it. hello developers conference. There we go. So that's very quick. So now let's configure our bucket to actually serve this file. So let's use the file system package to read the index.html file. So we want to create a bucket object for each file present in the public folder. So let's make a folder. Read each file present in the public folder. So we want to create a new S3 bucket object. There we go. And to that we want to pass file name. And we have a set of arguments also that we need to pass. So since this is going to be served over the internet, we want this file to have the ACL public read. And the bucket we want to store this file and is the bucket that we created above here. And I can reference to that bucket object. And we want the file to be stored as the same file name and set the source to the public slash file. So this is the path to the file that you actually want to upload, and for it to be served correctly to browsers, you must also set the content type to text/html. So here we go. Oh, whoops, that should be here. So now we are reading every file that is in the public directory, and for each file we are creating a new bucket object which is going to be stored in this bucket here. And the next thing that we need to do is to set up our actual bucket be hosting a website. So besides the name of the bucket, we have some orgs that we can pass. So we can say website. So we want to say that our index document is gonna be index.html that we are gonna upload. Notice how I got nice code completion while coding. And let's say I didn't know what kind of arguments this bucket object takes. I could just inspect it and have a look at the bucket args, and here I would have a list of all the arguments as well as the type. Is nice. So we are ready to deploy. One last step, we also want to get the URL of this bucket once it's deployed so we can access our website. So I'm gonna export the website endpoint of this bucket, and I'm gonna call it bucket URL. Here. So here we go. Now we are ready to deploy. I'm just gonna type me up. And once again, it's gonna preview our update. And since we have already deployed this before, it's gonna just compare what we defined with what's already been deployed and show us the changes. So it has seen that now we configure the bucket to host a website, and we have created a new bucket object which is index.html. And here in the summary you can see that it has to create a new resource, and one resource is being updated. Go forward and click yes. So our bucket has been deployed and we now have a bucket URL. Let's check it out in the browser. I'm just gonna copy the URL and paste it in the browser. And here we go, our static website is up. And that's pretty much it to deploy a website using AWS S3 bucket with Pulumi. And all that's left now is to destroy the resources that we have created. So to do that, the command actually is Pulumi destroy. And once again, we get a preview which tells us that we will have 3 resources which are going to be deleted. Go in and say yes. And that's it. That's the basics of how to get started with Pulumi and deploying a static website to AWS S3. And now we can move on to our second demo. So our second demo is going to be deploying an EC2 instance, which is going to be running a simple web server. And we're going to do that in C# this time. So let's go back to our demo folder. And once again, I'm going to do just for demonstration. And you can send the templates. We got an AWS C# template. But for the sake of saving time, once again, I've already created that template. So this time when we create this template, we have a C# project with the CS proj file, and we do have a program.cs and mystack.cs. Let's have a look at the program.cs file. So we do have a task which is trying to run a deployment of type mystack. So let's look at the definition of mystack. So once again, the default template comes with a bucket, and this time we want to deploy an EC2 instance. So we have the default template code over here, which I'm gonna delete. And we have to do a few things to get. So there's a few things that we're gonna have to do to deploy this EC2 instance. Let me just list them out so we can keep track of this. Firstly, we want to grab the Amazon Linux AMI, which is gonna be the OS running on our EC2 instance. And secondly, we want to create a security group. And lastly, we want to define our instance. So let's start with the first one. I'm actually going to cheat a little bit with this. And I'm just going to paste in some code which does the retrieving of the AMI. And we can see we have some references missing here. And the last thing is that if I hit Ctrl dot, I get code completion. Nice. And this is gonna retrieve the Amazon Linux AMI. And next we want to define the security group. So the security group contains a set of rules which define what kind of connection to the server is allowed. So let's start by creating a security group object. So go to new security group, and I can just add the missing package here, and we're gonna call it and it also takes security group arguments. And once again, if you're not familiar with the arguments, you can just go to the definition and read about it. It's nice. And so to that we want to add some ingress rules. And this takes security group ingress args. And once again, I can just add the missing pages. And we want the protocol to be TCP. And since we want to allow connections only on the port 80, running from port 80, port 80. And the final thing that we want to add is the interdomain routing block. This is going to be 0000/0 to allow any IP to connect to this machine. So should be set to the security group. All that's left is to define our actual instance. So let's create a new server. This is going to be a new instance object. And once again, we're going to give it a name, web server. And it's going to take instance arguments. And so we want to give the instance type. We're going to go for the free T2 micro instance. And now we have to specify our security group. And we're going to refer to the group that we created just above. So this is the group that we created, and just going to grab its ID. And again, the AMI, which we also grabbed up there. So I'm just gonna grab the ID from that. And lastly, the user data. So the user data is just a script that you want to run on startup. So, and for the web server, for this instance, we're just gonna run a simple HTTP server on port 80. So let me just grab a little bash script to do that real quick. So here we go. And let's just change that to say something a bit more interesting. So let's say hello from EC2. Here we go. And now I believe we do have everything. So once again, we have to output the URL to this EC2 instance so we can access it. So let me just change that to public URL, and here we're gonna do this, that public URL is equal to the server's public DNS, and this should give us a URL so we can access the server. So with that, I think we're ready to deploy the server. Once again, we do pulumi up, and this time building this project with .NET. And as our preview, and I'm going to do this update. So our server has been deployed and we do have a public URL. Let's check that out. And there we go. Our server is indeed running. And with that, we are ready to move to our third demo, which is going to be policy as code. And first, let's just get rid of those resources with pulumi destroy. And if you want to skip the preview, you can do --yes. Maybe just a little bit quicker. Let's clean up a little bit and we're gonna move on to policy as code. So policy as code is a set of rules that you define, and if ever any of your deployments is violating those rules, then it will prevent the deployment from going on. And the way to create a new policy is to type pulumi policy new. And once again, we get a few templates, but they are not quite the same as project templates. And this time, let's go with TypeScript. And actually, to be a little bit faster and not have to wait for dependencies, once again, I've already created the policy pack. So once you create that template, you will have a TypeScript project. Let's check out the index.ts. So this is our basic policy here. So as you can see, there's some imports at the top and we have a policy pack. So a policy pack contains a set of policies that we want to run our deployments through to see if they're violating any rules or validation that we might set. And in this case, policy does not allow S3 buckets to have public read or public read write ACLs. And we have an enforcement level, which is mandatory, which means that if we are enforcing this policy and we try to deploy a public S3 bucket, this deployment will be blocked. And the validation is done by this block of code here. It checks if the bucket ACL is public read or public read write. And if that's the case, then it's going to report a violation. So let's just give this template policy a go on the S3 bucket that we created in the first demo. So let's go back to our S3 website and check out the index.js. So let's say that we had the ACL defined as public read here, and let's try to deploy this S3 bucket, but with the policy that we just created, and we expect it to be in violation of that policy. So it's threw me up -- policy pack, then the directory of the policy pack, then the path to the policy pack, which is one folder up. And we can see the preview failed, and we have a policy violation here, and it's referencing our TypeScript policy pack and gives you the details about why it's failing. So it has detected that the SCL is public read and we are indeed violating a policy, and the deployment has been stopped. So this is how policy packs work. And this brings us to the end of my demos today. Hope you enjoyed. So that's it for me for today. There's tons of awesome examples. If you want to try it, follow me on github.com/pulumi/examples. And it's a pleasure sponsoring this event with Event Store, and at the moment we have a few open positions and we're hiring. If you want to know more, you can check out the positions on eventstore.com/careers. And feel free to get in touch with me on Twitter if you want to talk about Event Store, Pulumi, or grab one of those stickers on screen. Thank you very much. Back to the host. Thank you very much, Stesh.
Thank you very much, Neil, for this awesome presentation. It was short but sweet. So, any more things you would like to add to it?
And yep, be sure to tune in the following sessions from Event Store from today. We have an amazing session from Yorick, which is going to introduce the concept of event sourcing with Rust later. And yes, have a nice day, everyone.
Have a nice day, and we'll see you in 30 minutes for sharing.
We're SD Worx. Nous sommes SD Worx.
SD Worx digital assistant.
Consider it done.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail, and healthcare sector. We are proud to stand alongside South African banks as their technology partner. To name a few, ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services. Done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence to define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ our...
So, hello everyone, we are back now with Shavin from MCB Group. Hello Shavin, how are you doing today?
Yeah, I'm doing great, and yourself?
I'm doing great too. Good. Have lots of amazing sessions today. So, tell us a bit about yourself and your session.
Yeah, so hi, I'm Shavin, and today I'm presenting about containers and how to deploy and consume those containers. And let's go ahead, let's jump into the presentation. So I've been looking at a lot of great sessions in the developers conference in the past days, and it's going on amazing. And I saw a lot of great sessions, and that are happening, and some will happen today. So those are what I believe the sessions that would interest you if you're here. And I will try not to cover those stuff again because so that you can make good use of your time and you don't watch the same thing over and over again. And yeah, so all those sessions would be uploaded on YouTube. Please go ahead and watch them. And yesterday I was watching the one Docker versus Podman. I was watching it on YouTube, like not live, but later in the evening. It was big fun. Lots of interesting things to learn over there about containers, Docker, Podman, what's happening in the OCI world. And lots of things also with Kubernetes, with zero downtime deployment, which I also think it's very good, and lots of good stuff happening also today. So the agenda for this session will briefly cover containers, and we'll dive into container registry instances like ACI and Azure App Service. And we'll finish by a brief overview of Azure AKS. And what will happen in this presentation? I had a photo that I can no longer see it. I don't know where it is. Let me see. Yes. So wanted to start the presentation by showing this image. I think it's quite funny. Like the guys deployed his blog on Kubernetes. So I don't think I think it's very funny because there's a lot of hype on Kubernetes, and everybody is building their containers and want to learn Kubernetes and or deploying even things that I believe are not meant to be on Kubernetes, they're deploying it on Kubernetes. So in this session, I will show you like 2 or 3 other things that you can use in the Azure ecosystem, so that you can deploy your containers. It's like you don't necessarily need to spin up a Kubernetes cluster in all scenarios. And we'll talk about some options that are there that you can also use. Let's get back to the agenda. Yes, so in this agenda, we look at specifically Azure Container Instance and Azure App Service that you can use to deploy your containers. So why people use containers, like to be able to deploy easily on several environments and not having the problem that it works on my machine, like, and containers can run anywhere. You can run it on Windows, Linux, Mac, even IoT devices, and you can run it on any cloud. I think this is one of the very high values, that it runs anywhere. And it started to work on Windows, even if it's still a bit painful on Windows, but it works. You can pull your images and make it run. And one of the big wins also is that it works on nearly all clouds, if not any cloud. So if you have your packaging your apps into containers, you're pretty sure you can deploy it anywhere, and you're not restricted to only one cloud provider. And also it's also running on IoT devices such as Raspberry Pi. I tried it. It's a lot of fun also. And you might have seen this slide a lot of times. So why it's faster? It's because like it has a shared underlying infrastructure and operating system, and package your app with like your app and all its dependencies into only one container that you can move it around, which makes it work in theory like it should on most environment. So to start, like the flow of this presentation, I'll show you a brief demo of Docker, what I have on my machine, and then we'll proceed gradually to deploy this on the services that I just talked to you a few minutes earlier. Let's see if Docker is running. Yes, seems running. So in this super complicated app I have, it's a very complicated Java application that has a controller that returns something like hello world. We spent a lot of days building this. And I have the compiled version of the app in the target folder. And first thing to build your Docker image is you need to have your Docker file. So that's the Docker file. It's pulling the Java 8 base image, and it's adding the app into it, and it's exposing it on port 8080. And that's what we first use to build our app. So let's check what images do I have on my machine. Yeah, by the way, I did not practice this session, so a lot of things will be live. I hope it goes on well. So what I'll do here, I want to build this Docker image. And to build this Docker image, and we need the command which is called docker build. So I'll create a third version of this thing. And in it, let's change the Docker file. Okay, I'll add this file. So I'll create the first version of this thing here. So first thing that happens when I run Docker build, it will pull the base image that I specified in my Docker file. In this case, it's pulling the Java 8 image. So it's going very fast because it's already been cached on my machine. Like when I did a Docker images before, you will see that this image was already here. That's why it went very fast. So this basically now it built the image. So if I do now a Docker image, I see I have my image here, which I just built, and it was the version 3 of this image. See, it's just built. Everything's fine. What I want to do now, I want to run this image. Okay, I want to run this image. So what I do is I use the command docker run. I specify which image I'm running. So if you see, that's the image that I have, API app with the tag v3. I'm specifying that I will run this image, and I specify on which port on my machine will map to which port on the Docker image. So that's it, it's running. In theory, if I go to port 1000, I should be able to call my image. In theory, but let's see. Yes, okay, here it is. And that's it. Now if I check the processes that are running, okay, you will see I have this process that is running, and it's accessible through port 1000. That was it for a quick summary of Docker, and we'll use this to build on the presentation flow as we move along. Okay, now that we are moving into the Azure ecosystem a bit, let's see how we can now push this image to Azure Container Registry. So this is the container registry that is hosted on Azure in the Azure ecosystem. Nothing like force you to use this one. You can use Docker Hub or any other one that you want to. And Azure Container Registry, yeah, it's the one that we are going to use. This is a it's managed by Azure, and it can host several kinds of images, not just Docker. Again, if you want to know the difference between Docker and containers, watch this podcast that happened yesterday evening. Very good discussions there. And ACR also supports the familiar and open source CLI tools. And it has like a geo replication. That is, once you deploy your container, in one click, you can enable your repository in several regions for it to be distributed. Like if you're working distributed teams and you want to pull the images from the several locations, you can do that, and it will work quite well. So other things you get by using ACR is you get the possibility to use everything that's on Azure. Like it's secured. You can use Azure AD to like specify who can use the registry. You can use ORBAC to specify which users can connect to the registry and download what image. So it's really an enterprise tool. Yeah, let's go ahead and look at this thing. So back to the Azure portal. So like any cooking show that you watch, they often comes with some items that have already been prepared. So in this case, I already have my container registry, and this is in a resource group called DevCon, which I use to group all the resources I'm creating for this team. So yeah, this is my container registry, and it's accessible through this URL, which I will use in a few minutes. It has some features that I just talked to you that you would want to use in an enterprise world, like authentication, like encryption, to make it accessible for special networking networks like VNets, security such as ORBAC, and replication. I think we just talked about replication. Let me show you how it looks like. Yes, so you can, in just a few clicks, you can enable it in these regions. We also have South Africa, which is very nice, close to Mauritius. Should be faster to pull your images. And you also have repositories. So for in my repository, I only have this one. I already pushed version 1 and version 2 earlier. And yeah, just to show you how to create this, how it's called, the container registry, you just click on add and you search, like you can come in containers here and container registry and you wait. I don't know why it's slow, but yeah, it should come. Anyway, let's not sit here and waiting, but yeah, so you click here and you will get the form, you fill the form and should be ready to go. Okay, what do we have next? All right, next item that we are going to do. Remember, we created our images earlier. What we want to do now, we want to push this image in the container registry. First thing that you would want to do, you would want to log in. Right, so it already have my credentials. It won't ask me, else it would prompt me here to enter my credentials. And next thing that I need to do, I need to tag my app. So, okay, I'm pushing v3 and I will push it to this repository as v3. So I tag it, paste, okay. Now I need to push the third version of this app, push it. So it's preparing and it will push this to the container registry. So as we see here, it's saying that these base layers already exist because I've already used this machine and already pushed to this registry earlier. It was yesterday. So it already have this layer. So as you know, like Docker work with layers and that's wonderful. If I had not pushed this earlier, it would have had to push the Java image together with everything that I added to this image. So it would have pushed something that would be around 155 MB. Because I did this earlier, these layers already exist. Now it's pushing something that's only 16 MB, and hopefully it will finish in a few seconds. Yes. It's pushing now. If I open my thing, push, I think let's wait a few seconds. Okay, it's done. Now if I go in, where is it? Neil is feeling anxious because he came on the screen. Right. This thing is still loading. Wonderful. If I open, where it is, my container registry, and I go to repositories, I should see it here. Okay. Yes, so here is the third version deployed, and it gives you some data about it. And yeah, that's it. And it also gives you the command to pull the image. So as you can see, it's very, very similar to what you would do using the normal Docker stuff in any ecosystem. So nothing changes much here. I think that this also adds some value to be able to use the tools with the syntax and commands that you already knew. All right, what's next? Okay. Anything else? No. We already deployed it. Okay, 20 minutes already gone. New questions? Yes, so the next thing we need to look about is Azure Container Instance. According to Azure, it is the fastest way to run containers in the cloud. We'll test that in a few seconds. I don't know if it's the fastest, but it's fast, and it has a per second billing, and I'll show you the value of the per second billing in this demo. And it has no virtual machine management. I like that. You can run your container in a few seconds without knowing what's happening behind, and everything is managed. Some people call it the serverless container offering on Azure. I don't like these terms because it's very confusing, and even some people believe that there are no servers on the internet. Let's see. So the idea is you don't have to manage the infrastructure behind. It's managed by Azure. And yeah, that's the command. Nobody wants to look at that. And yes, where can this be used? So this is used in cases where you have a very simple backend that you want to host, or in examples where you have data processing or batch jobs. Like, these kind of applications that people create and they can run like at 10 a.m. every day to do something. Yes, now you can deploy this up as a container and use it in Azure ACI. And if you have very simple backends that don't need scaling and lots of complex logic, that's what you can come here also, because ACI is also production grade. It gives you lots of the benefits that you have by being in the Azure ecosystem. And it's event driven. And that's really cool. What I mean by that, let's say you're in a scenario where every day at 11 a.m. you want to run a job, and the job, what it does, it reads through some kind of storage. It picks all images that are there. It needs to run it through some kind of AI mechanism, like let's say image recognition or something like that. And this image, you need to pull it from somewhere. Once you pull this image and you want to scan it, and once you run the AI on those files, you want to destroy everything. So that's a good candidate for Azure Logic Apps. Let's say you are using, I think there's a slide on this somewhere. We'll come back to this later. And what not to use this for like zero downtime upgrades, not for this one, because you might want to go for AKS. For like service discovery, integrated load balancing, auto scaling, for this item, you would want to go on Kubernetes with AKS, because that's what AKS provides you. So those features, they are not competing. You need to know when to use what. Usually when people come to the cloud, they see a lot of things. They start by creating resources and they get a very high bill at the end of the month. That's because they are not using the right tools. You need to know when to use what and how to use it. That's very important. And let's go on a small demo here. So what we are going to do, remember that container that we already deployed on Azure Container Registry. What we are going to do now, we are going to deploy that on ACI and see if it works. So let's go. What do we need to do here? Okay. Let's back to our resource group. Okay, let's not click for this one. Let's open the Cloud Shell. So Azure has also the Cloud Shell. It's the small terminal that opens here that you can type all your commands. So it's requesting a Cloud Shell and it should come up in a few seconds. Okay, what we are going to do, we already have two apps deployed in the container registry. We have the version 1 and the version 2 of the container. What we are going to do now, we are going to use the az container create command from the bash console on the portal. We'll tell it to create an image with the name API app in the resource group devcon20. will tell it which image it needs to pull. So it's pulling from my container registry here, and it's the version 1, and on which port this needs to run. So let's copy this thing. Yeah, that's good. Okay, my Cloud Shell has been provisioned. I just need to paste it here, and that's my credentials. Don't try to copy that. Yes, so that's it. In theory, my container should be ready to go. Okay, that was faster than what I expected. Let's see what's happening in my resource group. Open it in a new tab. So now in my resource group, you will see that it has created one Azure container instance here, which is called API app. I open this, and if I browse to this URL here, okay, and that's it. My container is running. It took barely like few seconds, right? That was actually faster than what I expected. Okay. Anyway. Okay. Now let's say you want to create the same thing, but you want to add more resources to it. So let's open the ACI one more time. You will see that, okay, properties. So by default, when you create it, it gives you, I think, some CPU and some, so one CPU and 1.5 GB of memory. The other benefit here is that you can specify how much you need. If you need 1, 2, 3, 4 CPUs, you can put it here. If you need more RAM memory, you specify it here. For this demo's sake, let's say we want 2 CPUs and 4.5 RAM. And here we are pulling the version 2 of the image that we pushed earlier. Okay. So it's the same command, just I specified what amount of CPU and memory that I need here. So coming back to the per second billing thing, since you pay per second per CPU and memory, it can save you some time because you can decide when to run your container and when to kill it, and you can do it on demand and based on some events. So like I discussed with you earlier, that could be one scenario. Like we have we can use some kind of workflow in your orchestrator that's on Azure, and whenever an event happens, let's say there's an HTTP call or there's new files or you get, I don't know, a message, some kind of event, you can tell it, okay, go ahead and create an ACI container. It will pull the container and it will create the ACI, and then call the ACI, do any kind of processing that you need. When it's done, delete the whole thing. So that's where you benefit from the per second billing. And here we go, our second container is created and deployed. Note that it took a bit longer this time. Okay, sometimes it's faster than the others. I don't know how, but let's refresh here. So you will see that my second API app is deployed. Okay, and if I go in containers, properties, okay, this time it has 2 cores and 4.5 gigs of memory. And of course, you can view the logs. Yes, big Spring thing for this very complex app. Yes, so that's it. We deployed our app in a few seconds. Yes, so another use case is if you're using Kubernetes, especially with the virtual Kubernetes API now. And if you need to scale more and you don't want to provision more nodes, you can use the Kubernetes ACI Bridge API to spin up more containers on demand. And all this can be orchestrated by the Kubernetes master. That's also one use case. And one more use case that related to the events that I just talked. And this is an example where I have a pipeline. And when we're talking about pipeline here, there's another session that already happened earlier about pipelines. And what is this one doing? It has a create container command. It's running at a specific point in time. It creates the container, and it has a bash script that's doing some kind of work. Here it's just printing hello world. And when it's done, you can tell it to go ahead and delete the container. And that's it. You can do this stuff on demand just to save your cost. Okay. Next item. So that was for ACI, right? You can use it for backend jobs to even some kind of backend production grade and to spin it up on demand. But what if you need to host a front end app, like just a web app, and you don't want to go in Kubernetes to create a cluster to host a simple web app, and you want to have all the benefits of Docker? So one other thing that you can use is Azure App Service. App Service should have called web apps for containers, but that's fine. That was just me. So there's a new feature in App Service which is called web apps for containers. It allows you to host a web app in the app service, and you get all the benefits of the Azure managed app service, like security, compliance, high availability, scalability. So you can get the benefits of scalability and high availability and all the things you need to host a web app, but you can host it and you can do it without going to having the complexity of running a Kubernetes cluster. So app service is fully managed. Again, you don't need to worry about the underlying infrastructure. You don't need to worry about patching servers, installing servers, and things like that. It works both for Windows and Linux containers, and it can scale. Yes, so let's go and create that. Okay. So back to our resource group. And I already created an app service earlier today because we don't want to see the app service creating. Okay, what's in the app service? You have configurations, then there's container settings. So that's what interests us today. Let's hope the page loads. So the page is loading. What we want to tell it is we want to use a container from Azure Container Registry. We'll tell it which container we want to use, and in this container, which image we want to use and which version of the image. Deploy the version 1. We click on save. And we wait. So in theory, the deployment should have started. Let's see. Okay, so what's happening is you look at the logs here. You will see it's pulling the image v1 from the container. It's pulling, downloading, and extracting, still extracting. So the idea here is it will make the deployment for us. So the deployment is complete. It executed Docker run successfully. And if we go here, we should be seeing our app. Let's see. Okay. What's this? Okay, here we go, our app, it's running. We just did that in a few seconds again, but here the difference is we are running in the context of Azure Web Apps. We have all the benefits that Azure Web Apps offers us. For example, to manage your SSL certificate. As you can see, it's already HTTPS. You can scale this thing. Where is it? There should be scaling. Okay, that's your SSL settings, networking. You can scale up, that is, add more resources to your plan. If you want to add RAM, CPU, that's where it happens. And you can scale out. If you want to add more nodes, you can scale out, like add more instances. You can play with this and add more instances as you need. And you also have auto scale. That's really nice. That is, if you can tell Azure App Service to scale based on a metric. What kind of metric? You can tell it, okay, if this, like you want to scale based of this count, average count, let's say average, if the CPU percentage data in this queue, all this stuff, you can take decisions on. Let's say if you want that. If CPU percentage is equal to some kind of value, you scale it by, it is greater than this threshold for X minutes. Let's say if CPU is greater than 90% for 5 minutes, you want to increase the count by how much? And if the CPU percentage is decreased by what percentage in the last 5 minutes, now you can scale down. So it allows you to scale up and scale down. It's very interesting from a cost-saving perspective here. Okay, discard that. What other interesting things you get? Custom domains, identity, yes. Deployment slots, yes, I like this one. So deployment slots is about blue-green deployment kind of thing. That is, okay, we already have our website running here and it's running. We want to make a second release without having any downtime. That's something you would typically go with Kubernetes. You can also do it there, but in this demo, we want to do it without having these complexities. What you can do, you can add a deployment slot. You're telling it, create and let's call it slot 2, create a slot where I can deploy to, and once the deployment is done, I want to swap this slot. So there will be a swap that will happen at DNS level, and you will be able to access your new app, like the new version of the app, without any downtime. First, let's wait, because it's creating this slot. Okay, slot is created. What we want to do now, we want to open the second slot. And I'm going to container settings. I'm telling it what to deploy on this slot. Same thing as we just did. Select the container. In this scenario, we'll deploy the version 2 of the app and we'll click on save. So I'm doing all this like manually by clicking, but it could also happen via a pipeline. There's a nice integration with Azure DevOps and GitHub Actions that you can use to automate these things. So what it's doing now, it's spinning up the second container, we second up, but I don't seem to get the logs here. Something is funny. Okay, let's see if it's working though. Okay. Okay, it's not up yet. Let's see in container settings what's happening. Okay, so it's pulling the image. It's running, should be running. Okay, here it is running. Here it's running Hello World v2. So that's, look at the URL here, that's my slot. And here it's my, like, I would say, production website. So both are deployed, but my customers will be coming to this link. What I want to do now, I want to swap these slots without having any downtime. And to monitor this thing, there's a tool that I like to use, which is called Gatling. So what is Gatling? Gatling is, you can check their website, they call it load test as code, and it's written in Scala. It's very nice to execute load test. You can simulate like multiple users going to your website, like whatever amount of users you want to do. So let's see if my URL is good. Okay. What I'll do, I'll make it check this website continuously, and we'll see if we get any downtime. Is this good? It's good. It's good. Yes, looks good. Okay. Here we go. Let's run it. It will run this test. It will call the Hello API. And in the meantime, we are going to make the swap. Okay. We tell it to swap the URL. So it will swap slot 2 with the production one. Click on swap. It's performing the swap. If we look at our test here, we are getting Hello World. Swapping, let's wait. Let's see, it's coming. Hello World, still working. So at some point in time, you should see Hello World v2 or something, unless I really mess up the demo. Okay, here it is. We are starting to get Hello World v2, and we can stop that thing here. And we got Hello World v2, and there's no downtime. We got OK all the time. Yes, there's no downtime. Whenever there's a downtime, you would see the get API KO, this count would increase. So you can have a look at Gatling, also very nice to automate your load test. You can make it run in pipelines and things like that. So that was as easy as that to swap the slots. And if I refresh this here, you would see that on this URL now I get v2, and on the staging one, I would get Hello World. That's it for my super complicated app. And of course, the last thing to consider on Azure is also to look at AKS, which is the managed Kubernetes service on Azure. Also work using the regular Kubernetes API, and Azure abstracts some of the infrastructure complexities. And you can orchestrate across 29 regions, which is quite nice. But the best takeaway here is to know when to use what. There's a lot of benefits from using containers. Does not mean you always need to deploy your containers on a Kubernetes cluster. There's easier ways of doing that. In this presentation, I showed you 2 ways in the Azure ecosystem, and I'm sure there are other ways to deploy your container. So you don't always need to go with the more complicated one. Be smart, use only what you need, else in the cloud, it would explode your bill also. All right, that's it from me. And don't forget to check out the other sessions around DevOps containers that happened or will happen. There's a lot of value in these sessions, and all those will be recorded. You can also see them on the MSCC YouTube channel later. Yeah, thanks for watching. That's it from me.
Thank you very much, Kevin, for this session, and we actually really enjoyed the demo with Gatling and swapping the slots. And I will probably stop posting my blog Kubernetes now.
Thank you, Sherwin. I think myself, I will give Microsoft Azure a try for containerization, but I've been using Cubic for the while.
Yep, thank you, Sherwin. I personally really enjoyed the demos.
Hey, if you're talking, I can't hear you guys.
You can't hear us right now? Maybe we have a little bit of a sound problem on Sherwin's side.
Okay, now I hear you.
Oh, okay, great.
Yeah, that was me. I muted the speakers.
No problem. I was saying very nice demo with Gatling and slot swapping, and I will probably stop posting my blog in Kubernetes now. Thanks a lot.
Thank you, Sherwin.
Right. Thank you. Have a good day. Bye.
Good day to you.
Bye-bye.
Bye.
3.
Okay.
So welcome back everyone to the stream. We have Mr. Nadim Bahadur with us, who will be talking about natural language processing and machine learning with Apache Spark. Hello, Mr. Nadim. How are you doing?
Hi, yes. So thank you for inviting me to the session, and hi to everyone. So today's session is obviously on natural language processing. It's a big term. So for the purpose of this session, we'll just call it NLP. It's short and easy. And obviously, we will have a look at machine learning is also another big term. Machine learning and AI, right? Big terms at the moment. And the tech stack that we will be using end-to-end is Apache Spark. And it's a popular big data tool in the AI space, especially. But if none of these make sense, that's okay. We'll take you through a journey of NLP shortly.
Yeah. Thank you, Mr. Nadim. I must say, you have a very interesting and impressive resume of merging the financial markets with computer science. I'm very curious how that happened.
Yes, thank you. So thanks for the compliment, much appreciated. It's just I couldn't decide what to do, economics or computer science. So I've been coding since I was 13. And then I moved off to, do higher studies, and I ended up doing both. So this is what fintech is all about at the moment. And along this journey, I was mostly into finance, as you may have noticed. But finance today is actually data, right? And data is tech. So, and this is what we will see a little presentation today. The techniques that we learn are applicable to different domains, whether it's finance, genomics, text mining. The tools are the same, the domain changes, and that's what makes it very interesting today.
Okay, we are looking forward for the presentation. You can start.
Okay, sounds good. So we'll be just scrolling down through the slides because we had an issue with the full screens share. So so hello everyone. I guess we have a pretty interesting agenda, and so we will talk about objectives for today. We will try to use NLP to classify and also to predict something. Before we get started, there might be different people who are aware of NLP. So we'll talk a little bit obviously about what is NLP in the first place. Where does machine learning comes into play? So a quick overview of machine learning. This is not a course in AI, but just the basics for everyone to follow. But also why AI, right? Why machine learning? What's so interesting about this? And why is it so popular these days? Obviously one of my tech stack that I'm familiar with is Scala programming language. This may be new for the region in Mauritius and also Africa, but obviously very popular abroad. A lot of the tools that you're using today, tweaks, the big tech companies are very much Scala enthusiasts, and for good reason. So we'll have a little overview of that too. And Apache Spark, right? Apache Spark is a big data tool, very popular in the AI space. And as a matter of fact, Apache Spark is part of a Scala ecosystem, and we'll see that in a little bit. But our NLP pipeline today is something very real. So what I ended up doing for this presentation is I took the latest COVID-19 data set published from Kaggle.com. Kaggle is a very popular online database for AI and machine learning enthusiasts. And we're going to try to analyze text, so research papers that match to COVID-19 versus something else, something fun, so movie titles. Let's get started. So hi everyone again. So as was mentioned earlier, I couldn't decide between economics and computer science, so I ended up doing both. So that is pretty much fintech. And my journey has taken me through various tier 1 banks, building trading systems, and really it's all about data. data, merging technology, and across this journey, I've touched base across asset classes, from anything from fixed income to derivatives and to exotic climate risks. But at the moment, you can find me from my engineering blog, all about Scala. Yes, I am a Scala enthusiast, and I hope to share this the rest of the crowd today. And also launching a new social e-commerce platform in Mauritius called checkandco.com. And that also brings the idea of semantics and how things are connected together, and hence NLP. So, but enough about me today. Let's talk about NLP. So here's something real. We're going to try to analyze a piece of text. So given a title, imagine a stream of text coming through a pipeline, such as a Twitter feed, or even something as mechanical as loading different research papers. So how can we predict this piece of text is related to coronavirus versus movies? So if we look at the first text, clinical progression of patients with COVID-19, that's a title of a research paper from the data set I mentioned. So that's clearly COVID. So the machine has to be able to say correctly, well, if we receive anything similar, and we will understand what similar means, then that's related to COVID. So we want to classify this as COVID. The next one, The Avengers, well, it's a movie. We're trying to, so Avengers, clearly, it's a movie. So we want to classify that one too, something completely different. The next one, Mission Impossible, what's another title? Or a piece of text, right? Language, English in that regards. But NLP applies to obviously other languages as well. So that should be classified as a movie. And the last one is obviously COVID-19. But you can imagine this being a real system where a text is getting through the door, and we want to classify information. So how do you really go about, where do you start? So an NLP pipeline typically has different steps. And generally speaking, that's the same for any AI, different steps that you go through. Now, the very first step I didn't put here, but the very first step is to get the data. And that's actually usually quite intensive. You get the data, you have to play with the data, you might have to transform the data. But assuming we have text, so the cat sat on the mat. So in NLP, the pipeline is, you need to break down the terms into what is called as tokens. So that's what we do. So, and there is a particular function to do this. So it's a word tokenizer. The next thing, we want to know how often certain words or certain terms appear within this text. Now, term frequency is generally referred to the number that appears within a corpus of text. But for this purpose of this presentation, term frequency in itself can be expanded into different meaning. But for today, we'll just count it as a number of times the words, a particular word show up within a sentence. And the magic really happens where you need to try to differentiate certain word or token between each other, right? So for that purpose, you need to pick a model. So for today, I will be using a logistic regression. If that doesn't make sense, that's okay. We'll see what it means. But basically, you draw a line between two dots, and you try to classify one token on the left side and on the right side. Now, regression in itself is a bit more for today, but let's just think about it as drawing a line. But logistic is interesting because the drawing of a line becomes more of a curve. That means you can fine-tune your certain parameters to get the best outcome for what you're trying to. So obviously NLP pipeline is more advanced as well. In the English vocabulary, there are certain words that you want to remove, and these are typically called stop words. Stemming also, you might want to do that, things that are related to each other. So we're not looking at those today. We'll really focus on creating a pipeline. So the next step is, well, machine learning and AI. That's a bit scary to a lot of people. But at the bottom of it, it's not, right? We first need to identify what sort of learning we're going to use. So in AI, there is what is called unsupervised learning, or more things that connect naturally together, or a bit more automation. So clustering, neural nets, so networks, really, networks talking to each other. We're not doing this today, but we will do something what is typically more mechanical. Mechanical is a term, is an interesting term because it's something the human has more control by fine-tuning parameters. So in our case, we will be using logistic regression. So logistic regression, we will be sorting and classifying COVID-19 text versus movie titles. And basically, we're just going to put zeros and ones. That's all it is, without looking too much into the fine-tuning of these parameters. So anytime we see a text that relates to COVID-19, we're just going to label it as 1. The machine will know anything related to 1 is COVID-19. We get another text, and maybe it's the Avengers, so that's a movie. So we know it's a movie, and we're going to label this as 0. So now we start to classify using binary terms, zeros and ones, two different pieces of text. So COVID-19 versus movie titles. Now classification in this case is just, as I mentioned, between 2. But the supervised learning, they're different. You can continue to lift up your machine learning pipeline, different tools. So if you have multiple, I guess, things to classify or to differentiate, then maybe you might want to use a Bayes regression. So Bayesian regression becomes quite interesting. If you have to do a lot, if you're not sure about certain decisions before the classification happens, then you may have to look at trees and clustering. That means as you're progressing, you're trying to make certain decisions to group things together. And then once you have an idea of certain clusters of data, then you draw the line, the whole regression idea. But again, for today, we are going to take it easy and really focus on zeros and ones, as easy as it is. So anytime we see 1, it is COVID-19, and it's 0, it's the Avengers, it's movie titles. So yes, we spoke about machine learning, and it's very popular at the moment, AI as well, and it's a big hype, right? So, but what's really going on under the hood? So basically, a lot of problem sets, whether it's in finance, genomics. We're trying to look for patterns, things that relate to each other or have been have related in the past, and how we can predict something may relate again, so that we can make an informed decision. So machine learning is really about discovering patterns. And that's a pretty interesting diagram there on the genomic side. It's all about patterns. But for today, we will get to this through various tooling, and some of it may be new in this region, in Mauritius, and also in Africa. But as I mentioned, very popular overseas at the moment. So we will be using the Scala programming language. Now, there are many programming languages in the world. One of the more popular one, I guess, for a good few decades now has been Java, right? So Java runs on a JVM. We have a lot of developers on this talk, so maybe familiar with the JVM. So Scala was developed by Martin Odersky. But actually, Martin Odersky himself was working back then for SUN, and actually developed a lot of what in Java. And along his journey, there was a piece of research. How can we bring in more functional aspects to the JVM? And there's a lot of research published that you can look at. As he was working on generics as well in Java years ago, the next step came something what is known today as Scala. So Scala it's not a new language. It's been around for more than a decade now, nearly 2 decades to be honest, and has matured quite a lot. But it tries to fuse, bring all the features of popular object-oriented programming. We live in a world where we can relate to things, to objects, so a book, a car, a title. But what's happening, or what has been happening over the past 10 years is big, right? So in the past, we have been burying code with data. And that's great, but when you work through terabytes of data, you want to separate the two. And that's where functional programming comes into play. So you want to really function over data. So for example, in the NLP example, we might want a function to classify or to tokenize certain words. But the function is just that. It's a function like a sum, A plus B equals C. Something you can test, you can validate, and then you can throw in any piece of data into it. But at its core, Scala brings a lot more features. But one thing that's sometimes left is it works right out of the box with Java. So you don't have to change your existing code base. Just work with it. So the Java C and Scala C work together. And that becomes very interesting. So a lot of documentation online for those interested. On obviously the official Scala doc, myself from my engineering blog, and my book that I published last year. So feel free to reach out afterwards. But a bit about Scala in itself, as I mentioned, has matured quite a bit, has gone up the ranking, and there are certain good reasons for that, and we will see shortly. But the ranking is also synonymous of a lot of changes that's happening in the big data and AI space. We want to function over data. We want to be able to run computation in parallel because we are no longer dealing with gigabytes of data, it's terabytes of data. And even in Mauritius, there is terabytes of data in certain sectors. That we should look into, really trying to get insights about our data. But why Scala really? Well, Scala, pretty much there is something for everyone, right? So, and that's how the ecosystem has matured. So for today, we will obviously be focusing on Apache Spark. Definitely a very popular, if not the popular, big data. So running machine learning at scale, right? Using Apache Spark. There are other players, obviously, as the system and innovation continues. But Apache Spark is pretty much a de facto in the AI space to run computation at scale. If within the Scala ecosystem, high throughput messaging, whether it's through your Twitter feeds coming through or stock exchange prices being fed through, you want to be able to stream data. That's another big term lately, whether it's COVID-19 coming through or trying to classify different text. So streaming data, you want a high throughput messaging platform. So Kafka is there, very popular. And how do you deal with all these concurrent systems and data? Well, a lot of things have been built for you and ready to be used, including Akka streams, Akka clustering, and a lot of the nice things as well in the Scala ecosystem. It's very vibrant, right? Very mature. A lot of frameworks. If you are a pure FP programmer, functional enthusiast, there are a lot of tools for you, including Shapeless, CAT, Scalas. But if you just want to get a very nice middle tier website up and running as well, there's a lot of tooling for you, including Play, Akka as well, and build tools, right? Build tools plugin just to make your life easy. But pretty much there is something for everyone within this space. And the nice thing, as I mentioned, Scala just works hand in hand with a lot of the Java existing code base. Typically, it has been around at big organizations. So the move is actually not that hard. But for today, we will really focus on Apache Spark. And that may be new to a lot of you, perhaps. But Spark is in itself an ecosystem where there are different modules that you can pick and choose from. And that these were there from day one. The whole idea of modularization, I think, also played a big role as to how it became quite popular. So for today, we'll be looking at data frames, so Spark SQL, to look and read our data in, but Spark can also do streaming. And obviously, we'll be using certain machine learning libraries and the NLP ones. There's also graph libraries built in, but at its core, Spark and in the AI space, another reason why it became very popular, you have a lot of data scientists, right? And in different sectors or domains, you may be using R, for instance, in certain in finance, or in certain genomics sectors, but you may also be using Python, right? Or even Scala, or maybe some engineer wants to connect through using a legacy Java, and that is okay. And using Spark, you have various connectors. There's even now a C#.NET connector, even a MATLAB, fairly recent. So the whole idea that Spark is not prescriptive of which programming language you use. Obviously, there are benefits of data for certain things to use Scala, obviously. Less overhead, things like this. But at its core, you can connect using various languages, and that has been very powerful, especially in the AI space, because data scientists, as I mentioned, there are various sectors, and some sectors are influential, say in R. Others have existing Python libraries, and others might be new fintech using fresh Scala. So there's something again for everyone. So back to our NLP, we will again classify COVID-19 research titles versus movies. Something fun against movies. So the data set that I'm using, it's the latest published from Kaggle.com. If you're not familiar, Kaggle is the largest data science community. Any data set you're looking for, there's probably something there for everyone, from finance to stocks, genomics data sets, lots of tools and notebooks and examples for you to get familiar with these techniques. And obviously, another data set, again on kaggle.com, is the movies library, something fun. That one is from Cornell University in the US. To give you a few samples, so imagine a stream of text coming through our NLP pipeline, such as the one labeled for COVID-19 at the top versus the one at the bottom for movie titles. So for the purpose of this example, of this session, we will have two data sets. So COVID-19 text and also movies text. And yes, so now it's time to look at some code. There's obviously no need to memorize any of this. I published it on my GitHub on All About Scala, and feel free to reach out afterwards. But I've kept the example very fairly simplistic as well. So it's an NLP app, as simple as it is. There's a start, there's a stop. In Scala, you have built-in dependency injection. So when you launch the application, so I'm launching what is called a controller. I have all the things I need there for the framework I need. The framework needs a bunch of services. So dependency injections comes in right there. NLP services, something I made up. But once again, with Scala, the flexibility is there. If I want to swap NLP services for a test services, or you can just do that. So the very first thing we want to do is load data, right? So we will load two data sets I mentioned, COVID-19 text and movies titles, as easy as this. Now, when you load this data, we typically want to call it something, and that is typically a data that we will train. So we will train the movie titles to be zeros, if you remember from the logistic regression, and also COVID-19 to be labeled as 1. The next thing is the NLP pipeline, which is to tokenize each word, and also to find these term frequencies, and then to run as the logistic regression. But finally, we will want to predict, given some random text that I made up, can we predict clearly that this is a COVID-19 related versus a movie title. So as I mentioned, to get started, you need to connect to some services. Spark typically requires a context. The context is a cluster. For this session, it is just the PC that I'm using, so there's no cluster. You can also specify the number of cores that you want, things like that. Lots of configurations you can tweak and fine tune. And we want to do ETL, extract, transform, load, which is a very first step in any AI pipeline, as I mentioned, one of the more tedious one, because you want data that is curated, tested and validated before you actually do any advanced work on it. So for us, we are lucky because we are using the latest published COVID-19 data set. The data is very clean. So I literally just had to grab the COVID-19 titles. So if you look at this piece of code, even if you're not familiar with Scala, with programming, whether it's JavaScript as well, it's a function, right? It's a function or a method in this case. So we're loading COVID-19 data, and we want to get back out of it. A data frame is a construct that actually evolved from Python and then moved over to Spark. It's a way to look at from a high level data, right? You have columns, rows, but then there are many other features that it provides you, obviously. So to read this data, you need to have access to a Spark context, which, as I mentioned, is typically you're connecting to a grid, a cluster. But for COVID-19, remember that we are going to classify and label this data as ones, as easy as this. And then we load the second one, which is the movies, and we label it as 0. The next thing which in the pipeline is actually to create a pipeline. And if you recall earlier, in an NLP pipeline, you typically need to tokenize, which means to break down these sentences into words or tokens. From there, you want to find out certain term frequencies, how often certain terms appear, things like this. And as I mentioned earlier, there's over curation that you have to do, but we are ignoring at the moment, such as removing of stop words and stemming and all kind of over linguistic things that you might want to curate. But then we want to apply a regression. And for this purpose, we're going to do a simple logistic regression. And at this point, we have all our data for having a training data set. That means we throw this data to Spark in this pipeline, and we tell it, hey, go out now and train this for me. Label the zeros and ones accordingly. So once we have a training data set, we want to now trying to see if the machine has learned something, and we want to throw it. We want to throw at it a few texts. So the first one we will throw at it is the first text. This is the best Mission Impossible movie ever. Totally amazing. So clearly, a piece of text as this one should come back as a 0. That is, we clearly predicted that this is a movie title. And the second one is fairly long, but yes, it's definitely related to COVID-19. It's a global pandemic. So clearly that should relate to the data set for COVID-19. And what we will see in IntelliJ, sorry, the code editor is IntelliJ, what I'm using, and we'll see it shortly. We will see, hopefully, that we correctly matched these two sentences. And here's a live demo. So for that, I will now switch to my code editor in a second. Yes, so the screen has switched now, and just to show you again, the data set is really a bunch of sentences in a text file, but you can assume that this pipeline typically runs in a production system for classifying text or analyzing text, streaming of data coming through, but we are simulating it today all in one shell, say movie's title. The second one is the COVID-19 research titles from Kaggle dataset. Obviously, I took a snapshot. There's a lot more. And that's also something you typically iterate through in a typical NLP or AI pipeline, curating data and the cycle goes on. So I'll also show just how to kick off this project in case anyone grabs it from the GitHub space. So if you recall, the NLP app is where you start, and it does all the magic. We'll spend a little bit of time on the steps really for any machine learning pipeline in that regard. is really to load data, right? And when you load data that you're going to train, that is, you're going to apply some things on this data. And in our case, our loading of data is really, we're going to load movies data, and we're going to label movies as zeros, and we're going to load COVID-19 data, and that's going to be labeled as ones. The next thing is creating a pipeline. So this is a NLP pipeline, tokenizing the words, finding the number of frequencies, and also running a model, which is the logistic regression in that case. And then that gives us a training data set. And once we have the training data set, we will throw sentences. So the first one is related to movies, and the second one is related to the global pandemic, unfortunately. And we'll try to predict if the machine gets it right. So I will run it now. This is a live demo, always something interesting. So step one, we can see we're loading the data and training it. Now, typically over terabytes of data in a production environment, training data is not something you do live, right? You typically have training data that is hot and warm and ready to be used, because these steps take a long time, usually over terabytes of data. The second step, let me maximize this a bit. Yes, so the second step for us is to create an NLP pipeline that worked. So we had to tokenize, hash the terms, and run our logistic regression. But what we are more interested in today is the prediction. This is the machine learning bit and the whole exciting things about AI. Did we get it right or no? So in that case, everything worked fine. So we see a title. Title is from COVID-19. And the prediction here is just one. And that was related to COVID-19. And we output the text here. And then the next one is the label as 0, right? And if you recall, any sentences that sounded like or looked like a movie title, well, it had to be labeled as. So our demo was fine. I will switch back to the presentation. Yes, so nothing happened during the demo. So that's great. Nothing broke or anything. And things just don't stop here. NLP is an interesting space, but one word that comes in mind is, and also in AI, right? Things are related. So connections on things. So there's a term for this called semantics. Things have meaning at some point in time. The top left bit here, bitemporality, very to pronounce actually, but things have meaning with time, right? Why did I book this trade last year at this price, right? What was COVID-19 even a term used last year? Is it relevant today? Things like this. And graphs, right? It's more about connecting the dots. But when you look at graphs and semantics, graphs really gives you the high level. I'm a friend of a friend, or this molecule is connected to this other molecule. But really, in the AI space, you are interested into what happens underneath at different layers, subgraphs, right? And this is where we try to define, derive meaning and inspecting data. But back in Mauritius, right? AI is definitely a hot topic, also in Africa and generally everywhere, right? But AI is not just driving cars that drive themselves. I have a friend who actually works at Google and he tried it. And he did say it is something to really get used to, but it's not happening perhaps anytime soon, or maybe it will. Who knows? But robotics as well, right? A lot of interesting things happening in science. But at the moment, what we are always surrounded with data, so we should start making sense of data that we already have. And there are various things that we can do. And with NLP, just NLP, we saw text classification as a very basic example. And after that, typically you want to do a bit more digging, analyze what's going on under the hood. In real world, that brings us to things like sentiment analysis. Is my customer happy? Why is he or she not happy? What happened during communication, or things like that, or recommendation system, right? So people have similar things that they connect to, or even in things like cybersecurity, big topic as well, and also kind of related, really, KYC, know your customer. I'm getting a piece of text and email. Is this really the customer I've been used to dealing with, or is this a fraud, right? Market intelligence, big term as well, right? Really bringing Power BI to a shame, right? Power BI, right, is very popular. I have a nice pretty shell, nice dashboard. After that, it's just this. We want to know more about what's going on and where AI comes into play. Digging into the data, digging into the semantics. And yeah, so yeah, lots of real-world applications and in AI and also in NLP. All these things apply to NLP. And yes, and I think we're coming to a close now. And so thank you, everyone. And you can, hope you enjoy the talk. You can find me, I guess, at All About Scala, Check and Cool, LinkedIn. I'm active in Africa as well, African projects. So reach me for SABDS. And any questions? Happy to go back to the talk.
Thank you very much, Mr. Nadim, and very interesting and in-depth session about the inner workings of machine learning and NLP. I certainly really enjoyed it. So in the chat, we have Rangan, who is a fellow Scala developer in Mauritius, who says hi. And
okay, hello.
He's asking if you're willing to do a Scala meetup in Mauritius.
Yeah, it's a good advice. Yeah, we should definitely do it. Why not? Yeah.
And we also, sorry. Yep. And we also have Ashish, who is asking how he can contact you regarding NLP. I'll just put your details on screen right now.
Yeah, so the details I shared, my profile is online. You can contact me through All About Scala, LinkedIn, various different methods.
Okay. Very interesting presentation. You've introduced NLP, Scala, and a very interesting demo as well, merging COVID-19 and movie title. I'm very curious about your venture Check and Co. Is it already launched yet? Can you tell us a bit more and the challenges?
Yeah, thanks for it. It's a help out with COVID-19. Business came to a stop for lots of SMEs. Yes. But we can't do business, I guess. You can't scale a business just for email, right? And that's okay for a small one. But after a few emails, you get a lot of headaches. So bringing automation, bringing semantics into trading SMEs, e-commerce is the plan. Is the whole idea of semantics, real time. Both for the customer and for every Mauritian. So if I book an order, I don't need to now scroll through email, find the merchant. It's all in my dashboard. I log in. Lots of automation. So definitely check it out. So checkandco.com.
Okay, awesome. I was wondering, was there any challenges of implementing such a system in the local market that you've encountered?
Yes, absolutely. I mean, it's just live. We're on a soft launch at the moment. So we'll be onboarding a number of SMEs. So do get in touch. Lots of SMEs out there. But challenges is capacity building, right? So the product has a good feature list at the moment. We can scale as needed. It's all on cloud. But the cloud does not run in Mauritius. We can bring the cloud to Mauritius or closer as needed. So see, these are really some of the challenges. And the more feature sets that we receive from the business community, happy to add. And these would be really the main challenge will be infrastructure, right? But with cloud, lots of things we can click of a button today.
Okay.
Thank you. And I think we have one last question from Mangan. Oh, actually, we have some questions coming in. So Mangan is asking, where do you see AI in Mauritius? So maybe in what sectors do you see AI in Mauritius?
Yeah, I mean, the first one is fintech, right? Finance, KYC, right? I need to know my customer, right? Banking, I want to be able to do fraud detection, right? A customer has multiple accounts, right? Why is that? The person I'm dealing with in Africa, is it the real person I'm supposed to know? Does he have other things related abroad? So the whole idea of semantics, again, come into play. Finance, definitely a big one. And then obviously, e-commerce is booming in Mauritius. We want to understand customer behavior. We want to know, and also I don't want just to receive a piece of advertisement saying, hey, buy this ice cream today. We want to send the customer something that relates to him or she. So we want to bring semantics, right? The big word again. So yes, lots of interesting projects in Mauritius as well. There's obviously some pharma initiatives as well in Mauritius. COVID-19, we should get involved, right?
Thank you. And we have a question that just came in from Pravin, who is asking, have you worked with robo-advisors on market analysis?
Yeah, so online chats, chatbots, these are interesting. And there are definitely a lot of off-the-shelf ones that get you up and running literally by click of a button through a cloud provider. But once again, you want to derive meaning for your particular context, for your particular domain. So one, what's interesting in finance had a little play with was in the insurance sector abroad, obviously, that's bringing AI into chatbots. So I can log in and buy a policy, or the chatbot gives me correct information. So training that data set becomes interesting. And also in the call centers, right, at the end, right, we are already very active in various chats abroad with foreign businesses. We can elevate and lift our feature set by training this data and not just taking in what the client is asking, but also going back to the client and saying, hey, by the way, you can do this and this and this. Here to help you. So yeah, flipping the question back to them and keeping that cycle going is really looking at data. Chatbot is very interesting because you bring in streams of data, right? Similar to the example I mentioned. You have text coming through, right? And you need to be able to, I guess, create or predict something quite quickly.
Thank you. Sure. And we also have Samia in the chat saying thanks for the great presentation. And I think this brings us to the end of this session.
If anybody is interested in starting to learn Scala, kickstart your learning with Nadim's book, Scala for Beginners, available at allaboutScala.com.
All right, thanks. Also the
Thank you very
online,
much.
lots of examples there.
Thank you for your time. Bye-bye.
Thank you. Cheers. Bye-bye.
Bye-bye. And we'll be back in 10 minutes for the next session. See you. free.
Okay. Hello, good afternoon. Today I'm going to talk about event sourcing principle in Rust. And about me, I'm Yorick, and I'm a software engineer at EventStore. And if I'm not hacking some code in my Vim editor, you will probably find me at the gym under the squat rack. So what is event sourcing? So in order to answer that question, I propose you to first introduce some keywords we're going to need in order to go forward. And first, we need to talk about what an event is. And an event is a fact of a system that happens at some time. An event data is immutable, but an event does not have to comply to a specific template. However, we will usually recommend to have at least 3 key properties. And those keys are the following. First, we at least need a type. A type will help us to classify events based off a given property, though in this case, the type. So think about type the same way you will think about type in a programming. Then we need an ID properties because it will be useful to be able to identify a given event. So it doesn't need to be globally unique across your system, but usually we tend to use UUIDs. And lastly, we need to have a date property just to be able to know when the event occurred. So we saw what an event is. I propose you now to see what a stream is. And streams are a set of events that is sorted in a timely manner. Streams are an append-only abstraction, so you can only do 2 kinds of operation. First, a read, and that read can append in either backward or forward, and append. And because it's an append-only abstraction, we can't delete event in a stream. And like event, stream don't require to have a specific template. However, I think we can at least come with at least one property, and that property should be to be able to globally identify a stream. And for simplicity's sake, I propose to either call that property a stream name or a stream ID. And we usually tend to have a semi-human readable stream name. For example, let's say account dash followed by some random UUID. So here's an example of what a stream would look like. So you can see that we emphasize on a set of events that goes into one direction in this case. So account created, item added, and order sent. We saw what an event is. It's a fact in a system. A stream is a set of events, and now we'll see their sibling, which are commands. Commands are very similar to events in the sense that they share basically the same payload usually, but the main difference is event is about the intent to change the system. So usually when you want to change a system, you need to validate it, and command go through a validation process. In the end, when they pass the validation process, they are promoted into an event. So the difference is purely semantic. Command is the intention to change something. Event is the proof that something has changed. So we saw events, a fact in the system. We saw stream, that is a set of events. We saw a command, that is the intention to change a system. Now it's time to talk about views, and views are a computed representation of your application state, and it's not the representation of your application state. You can have multiple different views, and views are also called read model for that matter. And a view is built by reading streams recursively, and it is views are very flexible as such, because they are easy to change. But conversely, in some situations, views can take a lot of time to build when the number of events increases over time. So views use probably the oldest recursion scheme of all time, and usually in many programming languages, it's called a fold. So it's about a function that takes two parameters, a state, an event, and a new state. And we usually call that function a view computations. A view have an initial state, and when fed with events, that state change over time and at each recursion step until there is no event to process, and the resulting state we have at the end is the view. So in Rust, you can build a view functionally or imperatively. Semantically, both versions are very similar. However, the functional way offers nice perks like being able to see what has changed between two transitions, whereas the imperative way tends to perform better because a variety of views computation perform better when using in-place mutation. So we saw events, a fact in your system. A stream is a set of events, command, the intention to change the system, a view that is a computed representation of your system. But now we need to talk about the main, probably the most important piece of an event source system, the event store. And what an event store is basically where you put all your events. And it will be very difficult to come up with what exactly an event store should do. However, I think because in an event sourcing application, event store is the source of truth, it's very paramount to be able to store your event safely. And speaking of safe event store implementation, my company, the company I'm working for, provide a great event store implementation named Event Store DB. It's a database that is built from the ground up for event sourcing, and Event Store DB provide many advantages. First, it's a very active open source project. It also provides professional support services. It can work in cluster if you have high availability requirement. It can be accessed through many different programming languages. For example, we have C#, Java, Rust, Haskell, and very soon JavaScript and Go. Also, in the very near future, Event Store DB will release a multi-cloud software solution as a service, which currently supports both AWS and GCP, and later it will also support Azure. And here's an example of the administration landing page, where you can appreciate some runtime metrics here, and also up top a list of all the services available in the database. So here we can also have a detailed view of event, and you can see one of those property I mentioned earlier. We have the stream name, so in this case it's account-123. We know that it's the first stream of the event of the first event of the stream here, as its index is 0. We can also have a look into its payload, where we have an ID and a name property, the type, which is item added. And don't be fooled by the timestamp. We don't recommend to use timestamp as a date in your system. It's just a technical date which says that event has been saved at that time. So it's not really related to your application. Anyway, so now we have introduced keywords of event sourcing. I propose to implement a game, and I decided to pick a famous game. It's Connect 4. So Connect 4 is a two-player connection board game in which a player chooses a color and then take turns dropping colored disk into 7-column high 6-row vertically suspending grid, and the pieces fold straight down, occupying the lowest available space within the column. So it's a great example to get your feet wet when you want to understand event sourcing. So we will do the same thing we did earlier. We're going to see what kind of event we're going to have in such game. So we will have first the game created event, and that event will mark when a game has started. So it will have the two players that involved in the game, a date when that game occurred, and an ID, because it will be useful to be able to identify a game. Next, we have a token placed event. Token placed event will indicate a player made a move. For example, a player decided to play the red token at some column. And in this case, we only have the color of the token that is being played, and also the date when the play occurred. Out of the gate, with only two events, we're able to derive multiple views, like being able to map all the games ever played, or the state of the game board. And out of those views, we're able to detect if a game is over, the number of game played, total or related to a player. So let's see what kind of command we have. And no surprise here, we'll have two commands, which the first one will be create games. And if you remember in the first part, I said that whereas commands are very similar of events that need to be validated first. And in this case, we are going to deny a game, to create a game, if one of the players is already involved in an ongoing game. So that will be the validation process for that command. Then we are going to have the place token, and in the same way, we are not going to allow a player to play a token if he's going to target a column that is already full. So based on those constraints, we need to construct our views first, because in order to validate a command, we need to be able to have the current representation of an application state. So we're going to start with probably the simplest projection, but yet one a very important one is to be able to project all the moves made by a player. So in this case, it's for every token place event, we are going to drop one token on the first empty slot here. So I'm going to explain later all those slot type. I will explain that in detail after that. And the other views will be to be able to project all the current games. And let's have a quick look on the right side of the slide, when you see that projections, that views have to handle two different events. And it's a composite projection view in this case, because when we have a game created event, we decide to initialize a game with an empty board, and also the player reference in the game created event. But when we have a token placed event, what we do is just to delegate that event to the board view computation, where we project the token places onto the board. So now we're able to project our application state. We can safely implement validations. So the first validation will be to check if we try to create a new game, if one of our players is involved in an ongoing game. So it will be very simple to do. We just go through all the games we have, and if that game is not over, we just check if the player involved in that game are also in the new game creation attempt. If it's the case, then we deny the creation of the game. If not, we can go forward. You also saw that there is a game over validation function in the previous validation function. And this is probably the most complex function of the talk, but it doesn't need to be discussed that much because it's pretty much very related to the game itself. But basically what we do is try to run to see if we have 4 in a row of the same color in all the possible disposition. So if we find a winning condition, we just return the winner of the game. If not, we say there is no winner, which means the game is not over. So the last validation function will be to validate if a move can be done, and in this case, it is very similar to the function that will project token place event. It's basically that once the action decided that the player want to place a token at a given position, we just see if there is an empty slot at that position. If it's not the case, then it means the column is full. Then we can't play on that column. So as you already saw earlier, we used some models, and I want to extend of those a little bit. So first, we need to introduce what a token is, and it's simple as that. It's just either red or yellow. It is what the player used to make their moves. We have a board, and a board is an array of slots, and slot can have 2 states. Either they can be empty or occupied by a token. And we decided to go with an array of a slot, mainly because it makes in-place update very simple and fast, even if performance is not a major issue, it's not a big concern in this example. And then we have the game model, and the game model is a very simple one. It's just the player involved in that game and the board of the game. Also, we also add an ID just to be able to identify a game across all the game. But you might start to wonder about how that differ from a regular application. And you will be right, because most of the code I've shown so far is probably very similar to any regular application you're going to write, right? And so what is event sourcing then? And event sourcing is really a simple part of your application. And it's just to ensure that all the changes that happen into an application are stored as a sequence of events. And you can see here the main differences between an event source application and a mainstream application. So in an event sourcing application, a state is computed. We also say it projected, so it's transient. Whereas in a mainstream application, the state is usually serialized, then persisted into the persistent layer. So when we do major updates in event source application, we tend to say we do event migration, whereas in a mainstream application we tend to do state migration, and state migration all usually involve schema migrations. Also, in event source application, there is no data leakage, meaning we keep all the history that ever happened in an event store in the application, whereas in mainstream, in a mainstream application, we lost why the states is value, because we lost the history, because every time we try to change something, we just do a destructive update. And it's also the same story with error connection, because error can happen. And in an event source application, we use what we call compensation events. And in that sense, try to think about what Git revert does, because it's the same principle. Whereas in a mainstream application, we usually go through a destructive update to fix errors. So let's get back to our game and try to see how we're going to implement command processing. So command processing, as I said, a command, because it's just signals an intent to change the system, we need to check if the command is valid. And as you saw earlier with the function we implemented, when we have a create game, we just check that we're able to create that game, and if we can create that game, we just return an event. In the same time, if we have a place token, if it's a valid move, then it means we can return a token place. So you see that we tend to handle command individually, but we can also return more than one event. But in this case, we just return one, but it doesn't need to be that way. You can return how many events you want. And it's the same thing. It's almost the same thing with event processing, but the main difference is related to the differences between a command and an event. Because in this case, an event already occurred, we don't need to do any kind of validation. So when we have an event, we just apply it as face value, because the event, the validation has been already been done upfront. So if we put everything together, you can see how we can integrate our command process, or command or event processor. And as a general rules, I really recommend to have your external dependencies outside of your command or event processor. And what I mean by external dependencies is either how you are going to produce a command, or how you are going to persist your event. The idea is to improve testability at the utmost, and usually it's easier to abstract over how you're going to obtain a dependency and just return any output of your processing as a result of your function. So if you have an external dependency, pass it as a function parameters, and if you got a process outcome, let it just be a function return. So what is the benefit of using events? Well, it's time traveling mostly. When you use events, you can start at any point in time, because remember, we advise you to use time in your event payloads. So you can start either in the beginning of your stream, but you can also start at any point in the stream. You can rebuild the entire application state at any given time, which is very practical if you know a bug happened and you want to know what was the state of the application at that time. Also, the logic remains in the code and not in the persistent layer, because usually when you tend to serialize the application state, you lost the code that caused that change, whereas in an event source application, because you only store data, you are sure that you have the history of the code that produce such event, and you just have to look into your source control software to do that. It's also very easy. It is also easier to do regression testing, because if you roll out a new version, one way of testing if everything is working as it used to be is to run all the commands you previously handled and see if it leads to the same outcome. If it does, it means there is no regression. So how does this translate into Connect 4 games? So by using events, we can, in that game, we can replay a game step by step, and we can do it forward or backwards. A player could also return at a point where a mistake was made. So think about it. Imagine you had a game, and you don't exactly remember which time things went astray, and you want to go back at that time and probably change what you did and see what will come if you have done that move. We can also create a game based on a move of other games, which will be which will ease, for example, training, because you can train certain situations, so it will make everything, every feature like this simpler to implement. So that's basically magic. At least that's how I see it, because it is very powerful. For example, when you if one of your user or whatever want to know, okay, what happened if I changed a rule in our business rule. It will be very impressive if I could apply that new rule based on older event that predate that rule. And usually mainstream application don't have that luxury. So that's a really nice selling point. But that doesn't mean that event sourcing is a silver bullet. It's not foolproof, so it's very easy to shoot yourself on your foot. And because of event sourcing flexibility, it's very easy to let you to be carried away and to over-engineer your solution. So you have to be mindful of that. And you also live with your past mistake with event sourcing. I want to be precise here. Every time you changes reach production, it means that event will be generated with potentially bad codes. So in an event source application, those events will stay there. So you have to live with it and make those adjustments in your code. Whereas in a mainstream application, if you saw you did a really bad mistake, usually you can put everything under the rug and just do some destructive updates. So keep that in mind. So to go further about event sourcing, I also gathered other topics to extend your discovery of the event sourcing theme. So something that will happen very recently that will happen at some time when designing an event source solution will be about event versioning, because your system will change over time, and you will still have to maintain previous event of your system. So I really advise you to look into event versioning. There is also domain-driven design, which use event sources at its core, but add a more tailored design based on your domain application. We also got common query responsibility segregation, CQRS, where we try to separate our read application from our write application, and one benefit is to have better time to be able to optimize your application based on those requirements. So for example, you will tend to optimize read application because you know they only do reading, and maybe you will lower the power usage of your write model because you figure out you don't writing that much. And and there is also event modeling, which is basically probably a more straightforward design than domain-driven design, and also event storming. But most of this topic has been discussed by Greg Young, so it will be very easy for you to look into those informations. And also, we at Event Store hiring. So here's a list of the available vacancies we have. So hopefully, maybe you'll be my next coworker to join the team. And if you need to have more information about those positions, please follow the link below here. And that's all for me. So if you have any questions, just go forward.
Thank you very much, Yorik. It was a very interesting session, and we do have some questions from the community here. And firstly, Rust is not a very well-known language. It's not very popular in Mauritius. And do you have any tips for people who want to get started with Rust?
Oh yeah. I mean, me personally, the way I learned Rust was to pick something I like to do, and at that time, I like to write event store client code. So because I already made an Haskell client event store DB, I said, oh, let's make a Rust client and see how the language works. So personally, I will advise to do that. Usually, as a dev enthusiast, we have some tasks we really like to do. So I will recommend to pick something you already know and try to do it in Rust, because at least you will only have to focus on the language itself and not about knowing maybe a new domain, an entire domain, in order to make any progress.
Thank you, Yorik. That was an awesome presentation. You handled the English perfectly. I would like to ask a question myself. Can you tell us about real-life examples where event sourcing applications?
Oh yeah, for sure. I mean, maybe I can pick one I did in my previous job where I was working in a company that delivered parcels. It was a e-market company. So basically, we had users that bought commodities on the website, and we just shipped those commodities after. And my application was dealing with the state of those commands. So we got the whole history of the command, like when the purchase has been made, then how it will be dealt with the logistic subsystems, and we organized everything into streams, so it was easy to have the full history and to derive multiple statistics, like how many times that command took to be processed. And yeah, I think that's the bulk of the example. There is also other example that comes to mind. For example, which one I got in my head? Because I mean the most recent example I have is the example I just gave at my previous job. Probably I would like to think about more real life example now. But yeah, in my previous job, it was really good fit because we could do so many stuff like a projection about the current stock of one of one item, for example. We could also detect how many anomalies occurred based on the type of sales that happens, because each sale was different, so it was not carried out the same way other sale are. So that's why it was really nice to be able to derive in so many different ways the same process.
Thank you.
Thank you. We do have some more questions coming in the chat. And firstly, Rangan is asking, why did you choose Rust? And what about languages like NIM, C?
NIM? Okay. The first reason will be quite obvious. It's just because I happen to like Rust, even if my favorite language is probably Haskell. Why I didn't pick NIM instead? It will be easy to answer. It's just because I only know NIM just because I follow one guy on Twitter that talk about it maybe 2 times. He made a presentation about it. So I don't know too much about NIM actually. But to be honest, I also thought about implementing event store client on it because that's usually what I tend to do when I try to learn a new language. But we'll see. But there is no, I didn't pick Rust other than just because I like the language. I could have picked another language for that matter. And just I thought maybe there will be some interest about such topic with Rust. That's all.
Thank you. And the next question would be, how would you compare event-driven versus event sourcing?
So I need maybe more information here. When you say event-driven, what it entails exactly? Because even with event sourcing, people tend to come with their own definition. So I will need what event-driven in this case means precisely.
Okay, I'll see if there's any follow-up in the chat regarding that. So more information about what it means by event-driven.
Okay.
And one more question. How does event store compare to the solutions such as Axon?
Such as what?
Axon or Axon? AXON.
AXON. To be honest, I don't know what Axon is. So it will be hard for me to give to give an answer here. But I take note because I never came across that name. So you say it spells AXON. Okay, I will look into it because honestly, I don't know that product. So maybe maybe there is the same question for a different backend, maybe because maybe I could provide some answer with something I know at the very least.
Okay, there's a little technical question.
Yeah.
Does event sourcing scale over millions of requests per second?
It does if you do it properly. As I said earlier, event sourcing is not a golden solution that will make a bad design into a great design. If your design is bad, it will still be bad using event sourcing. So we will, being able to scale on millions of requests per second, it will need to be designed properly. And that's something that is beyond event sourcing itself. Event sourcing is more about being able to express your state as a sequence of events. And there is no more than that. The performance relying to it comes from your design decision, because as I said earlier, views, for example, tend to take more time as the number of events increases. So you have to be inventive in order to overcome that. For example, you can use a snapshot, for example, where you have an already serialized version of your application, and you just start at a different point of the event, just to not have to recompute everything from scratch. So yeah, I think that's something that is beyond event sourcing itself. It's a more design talk, not an event source talk, because as I said, event sourcing is not a magic pill here. You still need to do a good work. I saw a question here.
And we do have a little follow-up about the event-driven thing. So he did mean the difference between an event-driven architecture and event sourcing.
Can you repeat the first part of the question?
So to compare between event-driven architecture and event sourcing.
To be honest, I would have to know what that entails, but let's try to. I will try to answer that question. I mean, for me, what makes event sourcing is to be able to replay the event in the same way they happened before. So as long as I will say the main difference, if there is how those events been produced. Can in an event-driven architecture, can I still replay my event in the same way, for example, or not? Or because I think maybe I'm wrong here, but it looks like a question related for something like Kafka, for example, which use events, but I will not qualify using Kafka as event sourcing, mainly because it's a broker. So the only guarantee you will have when dealing event with Kafka will be based on how to say that, a shard. So the order is not guaranteed across the entire cluster, Kafka cluster. So you have to leak, for example, a lot of implementation details into your code in order to reproduce the same order. Whereas in an event source application architecture, it's the main property is to be able to replay the event the same way they occurred. It's not the only way to read those events, obviously, but that's a major property, is to be able to replay those events in the same order without having to link your event store implementation into your code, which will be the case if you try to do the same thing with Kafka, for example. So maybe I think it's a question related to Kafka. So maybe you should try to ask that person that, because it sounds like it. But if it is, for me, it's not the same thing. Because in the one way, it's not about notifying a system about a change. It's being able to query a system based on reading all the event that happened during the application life cycle.
Okay, thank you very much. We are nearly finished with the session. Oh, you're calling us from France, right?
Yeah.
It's maybe 10 o'clock there.
Yeah, it's 10:45.
How is the COVID situation going on?
It's really great. It's a wonderful time. We go outside, we play a lot. It's amazing time to be around. Yeah.
Okay.
So I hope I was able to answer the last question correctly, because I mean, it's very difficult to not be able to be live with the person, but I try to do my best. But just in case, I also mentioned my Twitter handler in the beginning of the talk, so feel free to ping me there, and I will gladly extend that conversation down there.
Yeah.
Thank you very much for your time.
Thank you for having me.
And yep, hope we see you soon in one of our other events. And bye bye.
Yeah, bye bye. Have a great day.
You too. Ciao.
Bye bye.
And that was it for this session. Thank you very much for following this session, and we'll be back in about a little more than 10 minutes for our next session, which I believe is about Kubernetes. Yes, that's right. So see you soon. Free. Hi everyone, so we are back a little bit early and we have Dennis with us who will talk on databases on Kubernetes and why you should care. Hello Dennis, how's it going today?
Hello guys, thanks for having me again. It's a beautiful day here and yeah, be back again.
So can you tell us a little bit about your session and what's going to be about today?
Yes, so I think that in the list, it was one interesting topic for me was that 3 years ago, most of people were totally against running stateful applications on Kubernetes. And it's interesting to see how this completely changed in just a few years. And now we are talking about, hey, how can you also run stateful applications inside Kubernetes? Because that's the holy grail, right? Like that's something super complex to manage, and that's essentially what this talk is about. So, how stateful applications can run successfully inside Kubernetes.
Okay, sounds very interesting.
Oh yeah. So your slide is now on screen, and you can start. Thank you.
Okay, so thank you again for having me. It's really a big pleasure to be here again. That's one of my favorite talks, to be honest, because I really like this topic, because a lot of developers are a bit skeptical about this, and I would like to show you guys today how this is in fact a very the state of the art in technology, I would say. And yeah, that's definitely something that I hope you guys enjoy. So for those who never heard about me before, my name is Dennis. I am, let me just start my watch here to be on time. So my name is Dennis. I am developer advocate at Couchbase. I have been working for developing software for over 15 years, mostly in the NoSQL and Java space. And I'm also active open source contributor. And I would like to start with a small tip for you guys. So whenever you are reading an article online, if the article starts with a question, the answer is usually no. Are all real articles from 2016 asking, should I run my database on containers? Should I run my database on Docker? And back then, the conclusion of those articles were, okay, no, you should not do that. And the main argument was that containers were designed to be stateless, right? And that's still true. Containers, in fact, were designed to be stateless. If we fast forward to 2020, you see that the articles now are not questioned anymore. In fact, you can see articles since 2018 saying, hey, running databases in Docker at scale. And that's something super cool to see, like how we, in just like 2-3 years, we completely changed our mind. And the natural question, you can see that the articles now are not questions, because they usually say, yes, you should run your database or your stateful application on Kubernetes. And the natural question here is, okay, what have changed? Why in just 2 years we completely changed our minds? There are a bunch of things that changed since then. I would say the first one is production grade images. So pretty much all the database providers now have official images, and they tested the database to be sure that it runs properly on Kubernetes. Of course, running on containers, not on Kubernetes, but and containers are definitely easier to set up and run compared to installing yourself on bare metal. You can also separate storage from compute, which is a really good thing when we're talking about big data in general. And of course, Kubernetes now in the last 2 years, which is essentially the main topic of this talk. So, okay, let's say you want to deploy MySQL on Kubernetes, right? The naive way to do that is essentially you create a deployment and then specify the MySQL image, and then you create a service to expose this image to the service, to other pods. And then if you apply this to your cluster, boom, that's essentially what you end up with. So one MySQL instance with a volume attached running in a single worker. But of course, if the workers goes down, boom, your database is offline. So this is not much better than running on a bare metal so far. Okay, so it's obvious that our database running in a single instance is not something that we should rely on, because we won't have like high availability here. So you decide to run 2 MySQL instances now. But if you don't understand how Kubernetes works, and you never heard about Interpod and Affinity, you might end up with something like this. So yes, you have 2 instances running of MySQL now, but again, they are running the same worker. And if the worker goes down, boom, you lose your both databases are not available anymore. Both instances are not available anymore. But the problem is that, okay, even if you configure everything properly, and now you have 2 MySQL instances running in different worker nodes, still, if you lose one of the worker nodes, Kubernetes will eventually bring this node back, because that's how Kubernetes works, right? So it will bring the node back, but we are talking about a stateful application here. So Kubernetes will potentially bring this whole node back, but it is all empty, and it also has no idea that, okay, you should also be connected to this other cluster here and synchronize and have some kind of data replication. So even though we configure everything properly, it still feels like there is something missing. And yeah, with that, I would like to give my first demo here. So first, let's show you something. So Kubernetes allows you to do something like, we already have on Kubernetes some default types, which are like deployment, service, and let's say pods, and etc. And then you can also create new types there. So in this case, I will create a new type called to do, right? This is, I could give whatever name I want to, but I'm just to specify a new type and say, hey, Kubernetes, there is a new kind of type here. If we compare to like application development, this will be similar to create a table in a relational database. So, and in order to do that, all I have to do is to come here to my, so I have here kube control, get nodes. I have 3 nodes running on AKS here. And then if I want to deploy this, insert this new CRD, all I have to do is to run kube control, create -f to do CRD. And okay, now I have this to do CRD. And now I can insert a new type, to do type on my configuration on Kubernetes, and I can define this new type, insert this new type there. This will be similar to inserting a new row in a table. So, and in order to do that, all I have to do is to run kube control, create -f to do .yaml. Okay, and now, because I have defined here on my custom resource definition that I have the kind to do and the plural is to do's, I can run kube control get to do's, and it will list all my to do's here. Or I can run kube control describe to do buy milk, I think, and then it will describe this content. Okay, so this is how we could store a configuration inside Kubernetes. Why this is important? So essentially, because I can store the whole configuration of my database there. So essentially, let's say in my case, I work for Couchbase. So let's say I want to store the whole configuration of a Couchbase cluster there, or a Couchbase node. So I can create a new CRD, which I already did before, and then insert a new type called Couchbase cluster, and then specify all the configuration of the cluster here. Why is that important? Because on Kubernetes, we have something called the operator framework, and the operator framework essentially allows me to extend Kubernetes to listen to events, and the thing is, whenever I change something on a CRD or whenever I insert a new YAML file, it will trigger events, and those events can be listened to an application that will trigger some actions. So, for instance, whenever I insert a new Couchbase cluster YAML file there, the operator, which is just an application that I deploy on the Kubernetes cluster, will listen to this event and then say, hey, oh yeah, there is a new Couchbase cluster YAML file here. So let's spin up a new Couchbase cluster according to this configuration. Or let's spin up, if I insert like a new MySQL cluster, for instance, this specific application will listen to this event and say, hey, there is a new MySQL cluster definition here. Let's spin up all the nodes that we have. So just to show you guys how this will work, this will look like on Kubernetes. We have the operator here. The operator is essentially stateless. It can run in whatever node. It's actually one per namespace. And then whenever you insert this new YAML file, it will listen and it will do whatever you have defined it to do. Of course, you have a specific operator for each kind of application. So let's say here I have a Couchbase operator, but you could have a MySQL operator, a Postgres operator, Elasticsearch operator, and so on. And one of the cool things of operators is, okay, you can also apply some human knowledge there. So, for instance, if a pod dies or you lose a whole node, the operator will listen to this event and say, hey, looks like a Couchbase, we just lost a Couchbase pod here. And then the operator knows how to recover from that. So I can lose a node, and then the operator knows what are the steps to recover the database and bring this back to a health state. And the advantage of this is that I can essentially, if I have a good enough operator, I can have something like a database as a service inside my own cluster. So let's do this now live. Essentially, what I'm going to do here now is I already have two things running here. So kubectl get pods. Oops, pods. So I already have two things running here just to save on time. So I have the operator and where's my mouse? So yeah, okay. Go back here. Okay, I have two things running here. One is the operator, which is usually provided by the software vendor, or you can build your own operator, or you can just use some open source one. And the second is the admission controller. Admission controller is just how you can validate a configuration before it gets inserted inside Kubernetes, because the operator only listens to events, and if you enter the run configuration file, it will mess up with the operator because this is not a valid configuration. So the operator is just how you check and validate the state of the YAML file that you're inserting. And what I have to do to deploy, let's say, a Couchbase cluster here. So I have here my secret, so secret YAML file. This is just means administrator and password. And to add this secret here, I have to run kubectl create -f secret. Okay. And now to deploy my Couchbase cluster, I can run kubectl create -f Couchbase cluster. Okay, so let me show what's happening here. So now if I run kubectl get pods, in fact, let's say watch, you see that I already have CB example 000 here. What is happening is in our Couchbase cluster here, this is just an example. It will pretty much work the same with MySQL, Postgres, and any other database out there, essentially. But what I have defined here is, okay, I want to deploy this Couchbase cluster, and I want a bucket, which is similar to a schema, called Couchbase sample, with like 108 megabytes and 3 replicas, so 3 copies of the data. And then what I'm saying here is I want 3 nodes running data, index, query, and search, which is essentially the service that Couchbase has internally. And what you can see here is that, okay, now we have CB example 001, and then we have 00, 001, 002, and hopefully soon they all will be available already. In the meantime, what we can do is, okay, let's also deploy an application to insert data, dump data inside this database here. So I already have here, so I have here a very simple Spring Boot app that will insert data inside Couchbase every X seconds. So let's in order to deploy this app, I have to run Spring Boot, kube control -f, create -f Spring Boot app secret. So this is the password that a Spring Boot application will use to connect with the database. And then finally, my Spring Boot app YAML file here, which is nothing, there's nothing super special here. It's just a simple application that I created, that Spring Data app that inserts data directly on Couchbase. And now, hopefully, if we see here get pods, you see that, yeah, our database is ready. So what I can do now is let's forward the port to my machine here. So I will forward the port 8091 to my machine. And then if I come here to Chrome, let's bring a new browser here, and I can access localhost 8091. So this is the Couchbase web console. So when you install Couchbase, that's how you administrate Couchbase there. And then I enter administrator and password. Oops. Password. And boom, here is the node that we just deployed. As you can see, we are already inserting data inside the node. So this is my application inserting data. And here on servers, you can see that we have CB example 000, 0001, and 0002. Okay, great. So let's do one thing now. Let's come back here. Let's come back here to the bucket, and let's add a new bucket here, which is again creating similar to creating a new schema. And I will create here a new bucket called test. Okay, so now we added the bucket and we wait for the bucket to be ready, and boom, the bucket disappeared. Why is that? Because remember, we have defined here that I want just one bucket called Couchbase simple. So the YAML file is a single source of truth, right? And what happens is the operator that I have deployed is every X seconds comparing if this configuration here is the same that is configured is the same as the real configuration of the cluster. And because I have added a new bucket here, when it checks that, it says, hey, there is some difference in the configuration here. You have defined that you have Couchbase sample, but in the real cluster, we have Couchbase sample and test. And then so the operator essentially reverts this change. What else can we do? So we are inserting data here. The database is live. Let's try something very aggressive now. So we could try to just delete one of the nodes. So exactly what we described before. So we can come here and say kube control, delete pod cb example 0002. Boom. So we just lost. 3, 2. Okay, boom. We just deleted one of the nodes. So if we see here get pods, we just lost one of the nodes of the database. And we've come back here. You see that, oops, Couchbase noticed that we lost one of the nodes. But application is still live. Not a big deal here, because remember, this is a distributed database, so the other nodes can take over as we have replicas of the data. So the nodes will be promoted to handle the requests that are being sent to that node. And then what will happen now is Kubernetes will bring this node back, but remember, this is a stateful application. So bringing the node back is nothing. I still have to join the node, the cluster, join the new node to the cluster and trigger data rebalancing. So if you come here, you see that control get pods. You see that now we have CB example 003. So Kubernetes, before we had CB example 002. So Kubernetes already brought the new node back, and the operator will listen that, hey, there is a new Couchbase node here. I need to join this node to the cluster and trigger data rebalancing. And that's exactly so. You see that, oh yeah, we have a new node here, which was just added to the cluster. And then we need to move some of the data that were here in those two nodes to this new one, because this new node here was empty with no data at all. So he cannot answer any queries from the user. And you see that this is happening automatically without any human interaction. And yeah, and that's essentially one of the things, so how you can have a DBaaS-like experience inside your cluster. One important thing to highlight here is that in this case, I'm using ephemeral storage. So ephemeral storage means that when I lose the pod, I lose all the data in it. But it also supports, naturally, it also supports persistent storage, local persistent storage, and remote persistent storage. If I was using local persistent storage here, bringing a node back will be something super fast, because then I just schedule another pod to the same worker node and attach the same disk. So I could recover this in like minutes. But here I'm already like given the worst case scenario. So I lost all the data that I have in the pod, and I'm recovering this automatically. The other cool thing is, okay, what if I want to scale the cluster now? So instead of 3, I want 4 nodes now. I have to do to scale it up is to come here. Now that I have defined size 4 here, is to run control, CTL control, replace -f, Couchbase cluster, and boom. Now, eventually, as soon as the rebalancing finishes, the operator will start to scale out the database and then an extra node. It's important to also highlight here that so the rebalancing usually is a very let's say there is some limits on how fast we rebalance the database, because the problem is when you lose a node, right? Your performance is already downgraded. So in the first case, we had like 3 nodes, and we lost one of the nodes, and then we are serving the application with just 2 nodes. So your performance is already downgraded. So when we add a new node, we are very cautious with rebalancing to not make like, okay, to not rebalance as fast as possible, because this will impact the performance of our application as well. So we are very cautious with, we have some performance limits on how fast can we rebalance data just to avoid to make things worse. And of course, this is optimized for terabytes of data. So that's why it is a very, the transition is a very complex implementation. But here you can see that, okay, yeah, we already fully recovered now. If you come back here, control get pods, you see that we already, yeah, we will start to add, Kubernetes will soon, yeah, now we already added CB example 004 because we just scaled up the database. Some other things that we could do as well here. For instance, I could, let's say, I have Couchbase 6 here, but if I want to run Couchbase 6.5, all I had to do is to run Couchbase 6.5, change to 6.5 here, again, go back to the console, and then run kube control, replace -f, and apply this new cluster configuration. In this case, the operator also knows how to upgrade the database. So It knows essentially how to upgrade the database, and if something goes wrong, it also knows how to roll back to the previous state. Some other things that we can do as well, but this is more, I would say, more Couchbase specific. But in this case, we could do something like, let's say my application reads more than write. So instead of scaling everything, I could say something like, okay, if my application reads more than write, I could have like 4 data nodes and 10 nodes running index, query, search. Or maybe search here is full text search, because we also support that. But let's say you don't need full text search. So I can do something like this. So now my application, if my application reads more than write, I can scale just index and query and have just 4 nodes or 3 nodes running data. Or if it is the opposite, I could also run, let's say, 15 here and then just 3 here, because I don't query the data that often. I just insert data on it. And the beauty of this thing here is that I can adjust the service. I can adjust the hardware according to the service. So, for instance, data needs a very good disk, of course, so I can adjust the hardware there. Index needs more memory, so I can adjust the hardware to have more memory there. Same with query. So query needs more CPU, so I can again adjust the hardware according to the service that I'm running, and I have a lot of flexibility here to boost the performance, to fine tune the database. Okay, so that's, hopefully we should come back here. Yeah, you see that now we scaled up the database, and yeah, you see CB4, and this is all happening while the database is still online. So we are still inserting data in the database. And that's one of the beauties of database and Kubernetes in general. It gives roughly the same experience that you will have on if you hire the best solution out there. Okay, so let's go back to my presentation. So there are a bunch of other possibilities as well. So for instance, this operator, I'm using the old version of the operator, but if you go to the new one, it also supports automated backups. So you don't need to, once you deploy your database on Kubernetes, it can automatically start doing backups for you when you in a defined time, and then store this on a disk somewhere. So it's up to you. You can also configure, like, say, cross data center replication. So let's say you have like different one cluster running in Europe and another running in US or in Latin America or in somewhere in Africa. So you can configure the replication of data between those clusters. You can export all the metrics to Prometheus as well. So let's say you don't want to, you want to monitor some stuff on Grafana, so you can use the operator and the definitions here to export data there. Okay, so I would say that the future is essentially will be something between choosing a database as a service versus running on Kubernetes. Database as a service is, of course, is something super easy, and you have a very low TCO. So potentially, in most of the cloud providers, there is if you have a small database, potentially the best might be a good thing for you, because you can have like a good database for $100 a month, let's say. But the problem there is quite often it lacks flexibility, because you cannot fine tune their database. So if you need to get more performance, most of them don't have very limited ways on how you can optimize your database. On the other side, we have database on Kubernetes. With the major problem now is that, yes, the learning curve on Kubernetes is still a little bit steep. So you still have to spend some time understanding how Kubernetes works before feeling confident to run a stateful application there. But Kubernetes is already getting far easier than what it was like 1 year, 2 years ago. So I suppose that potentially that's the default option in the future. So but we will stop essentially running databases on bare metal just because we have this whole automated flow of self-managed and self-healing databases there. And guess what? That's exactly how, for the Kubernetes and operators, it's exactly how Couchbase Cloud works. So if you say, hey, no, I don't want to manage the database by myself. I prefer to go to Couchbase Cloud and just run the database there. Well, under the hood, we will be using the same Kubernetes cluster and the operator. That's exactly how it works. And in fact, that's because I'm in this field, so I know how other companies are doing it as well. And pretty much all of the other companies are also using Kubernetes and operators on their DBaaS, database as a service solutions, or they are migrating to this kind of a thing. So that's pretty much how, if you complain, hey, just last week actually, I answered a question on Reddit where the guy says, hey, instead of running database on Kubernetes, just hire DBaaS instead. And like, hey, that's exactly how it works under the hood. Like, you're still running database in Kubernetes there. Okay, we also need to talk a little bit about storage again. So ephemeral is once you lose the pod, all the database, all the data in it is also lost. So ideally, that's not you should be using for databases. We also have a remote persistent storage. So in this case, we're talking about Ceph and Rook or whatever options you have on Kubernetes. The problem with remote persistent storage is that quite often you have databases are disk IO bound, right? So they write a lot to the disk. And for remote persistent storage, one of the issues is that the latency between the database and the disk will impact your query performance. So you should not be using remote persistent storage unless you have a very good, a very low latency between the node and the storage itself. And since Kubernetes 1.14, we have local persistent storage, and yeah, that's pretty much what you should be doing with databases now. So with local persistent storage, you get access to the disk where the node, where the pod is running, so a local disk there, and then you get like nearly the same performance as you would get on a bare metal. Worth to highlight that. Yeah, I mean, let me just show you a graph here. So I just got this from KubeCon 2 weeks ago. And this is just a comparison between performance of remote persistent storage in blue and local persistent storage in red. So you can see that sometimes local persistent storage is essentially 4 or 5 times faster than remote persistent storage. So you definitely should prefer, while running a database, prefer to use local persistent storage. Another important thing here is that worth to highlight that local persistent storage is not a general purpose storage solution because, again, you are writing directly to a disk. So if the disk fails to lose the data that you wrote in the disk, the disk is, of course, not replicated. And there is some other steps that you should do to prepare the disk before doing local persistent storage, before using it for local persistent storage. So it definitely is not something that, okay, apart from anything that is not disk bounded, an application that is not disk bounded should not be using local persistent storage. And again, it's okay to use local persistent storage for databases because pretty much all databases there already have some kind of replication mechanism internally to copy the data from one place to another, because we are very databases. One of the jobs of databases is not losing your data. The main job, one of the main jobs of the database is not losing your data. So they are very good at replicating the data between other nodes. So that's why it is alright to use local persistent storage for the databases or whatever other applications that also keep copies of the data. In the past, we before local persistent storage was GA, we in general we used host paths, and essentially you should not use host paths anymore at all. It has been completely replaced by local persistent storage. Essentially use the volume claim framework, so it's very similar to remote persistent storage. So that's important to highlight. And one important topic that many people are concerned is, what about performance? So how how the database performs compared to a bare metal. So roughly 2 years ago, there is a famous benchmark for database called Yahoo Cloud Serving Benchmark, and which has a different kind of workloads to test the performance of the database. So roughly 2 years ago, we did some tests comparing Couchbase running on bare metal versus on containers in Kubernetes. And what we found out was that, okay, for some types of workloads, let's say in this case, workload A, we haven't seen any difference at all. But for workload E, which is, okay, I make a lot of small, short query ranges. So essentially, I ask for a few documents every few seconds. We saw that, okay, the performance downgrade of running on containers was almost up to 10%. So worth to highlight that this test was more than essentially almost 2 years ago, and since then some performance improvements have been made to Docker. And also I would say that most applications are not using just workload A type of queries, but still it's safe to say that your application running inside a container on Kubernetes should have a performance penalty of something around 2 to 5% performance downgrade. All those tests, they are not Couchbase specific, so I think you can extrapolate that to other databases as well. So whenever you are deploying a database on Kubernetes, make sure that you add some extra CPU and maybe memory to compensate this 2 to 5% performance downgrade. This is essentially the results of the test. So you can see that here we got like minus 1% performance decrease for this workload A. Here in the workload A, running on Kubernetes was even faster. Faster than bare metal. But here on the workload E, you see that we got almost 10% of performance downgrade. Okay, so Kubernetes operators is already a big thing on Kubernetes. You can actually build your own. There is a bunch of famous operators out there. So, for instance, for Postgres, I think one of the most famous ones is one created by the folks from Zalando. And MySQL, well, you have a bunch of options for a bunch of operators from MySQL. The ones for Percona is widely used, I think. And Red Hat essentially created this thing called Operator Hub, where they try to compile all operators out there. So you have like operator for Elasticsearch or whatever kind of application you can think of. And yeah, and I hope you guys can maybe this might be helpful for you, and you can start playing with Kubernetes and operators there, because it essentially saves a lot of time maintaining the database itself and other applications. So I have seen companies already that they finally could stop having like a 24/7 support of DBAs, because the operator can recover from most of the problems. And in general, even if something bad happens, usually the operator is good enough to recover after that. Most of the operators, they are stateless. I forgot to mention that. So they usually save the state inside etcd, which is the internal Kubernetes database. So even if the operator fails, it's all right. Kubernetes will bring the node back, the operator back, and then the operator will get its state from the etcd. So yeah, that's what I said. I just want to highlight again NetBit, which is a sponsor of the event, and also Couchbase partner. So if you guys need some consulting or need some support on NoSQL in general, make sure to contact these guys. And yeah, thank you very much. Couchbase also has an event called Couchbase Connect. You can register for free here, where we will discuss many things about NoSQL in general. So yeah, that's it what I have, and thank you very much. Thank you very much, guys. And if you have any questions, feel free to ask.
Thank you very much, Denis. So I believe Stej has gathered some questions from the chat.
Yes, thank you, Denis, for the presentation. It was very interesting. Running databases on a Kubernetes platform. Okay, for those who aren't familiar with Kubernetes, can you do a quick recap, brief, comparing the advantages Kubernetes have and the disadvantages of hypervisor VMs, and in which scenario do you think VM could have an upper hand?
Well, the problem with, containers, the advantage of containers in general, especially on Kubernetes, is you can define exactly how much memory and CPU you need. So instead of, like, say, create a VM that your application might not be consuming all the memory or all the CPU there, you can define exactly you can better utilize the hardware when you're using Kubernetes. Containers are, of course, easy to manage in general. So if you need to scale up and down, there's a bunch of mechanisms inside Kubernetes to be elastic. So for instance, in this case here, you can even make both your application and your database elastic. So let's say you have, I don't know, Black Friday. So and if you define a set of parameters here, Kubernetes can outscale the application and the database for you. One of the important things here is that it is cloud provider agnostic. So it doesn't matter if you're running locally or if you're running on AWS or on OVH or on DigitalOcean or Google Cloud. It will be the same configuration, and it allows you to kind of go to the places where it is cheaper, because pretty much works the same there. You have the same benefits everywhere. Compared to VMs, I would say that if you have a very simple application, potentially VMs is better for you because it's simpler to manage in general, and there is a big I'll say the learning curve. And to start with Kubernetes, you have to learn a lot of stuff. So in general, if you have just a few applications to manage, VMs might be a better solution for you. But otherwise, I think pretty much most of the companies are migrating to Kubernetes now. You also have an option to use those managed Kubernetes service, which is really helpful. It makes the life easier in general. That's exactly what I'm doing here. And yeah, and I mean, maybe I have answered the question. Do you have any other questions?
Thanks. A very interesting thing you mentioned in the beginning of the presentation, whereby in case of failure of a node, it will auto restart. Are we notified by any event, and is there any way to control its parameters? For say, if the CPU hits 85%, is there any way you could do that?
Yeah, so that's a good question. So, so in Kubernetes, we have something called pod outscaler. And the pod outscaler, you can define when should I scale up the database. Instead of doing this manually, I could say, for instance, when not just the database, but pretty much every single container you're running, you can say, okay, if the CPU is on 80% for 5 minutes, spin up a new node. And of course, you can limit, okay, you can scale to up to 10 nodes or minimum 2 nodes. You can do all the sort of. One other thing that is super cool as well, which is since Kubernetes 1.14, I think, as well, is that you can define your own metrics. So you can say, if by some reason I have, let's say, 10,000 rows on the specific table here that I'm using as a queue, for instance, you can, if I have over 10,000, scale up the pod as well to make for my applications to consume that. Or if I'm using, let's say, Kafka, and I have too many applications in the queue, message in the queue, I can also use that to scale my database. So you can define whatever parameters you want to use with pod outscaler to scale up and down your cluster. The cool thing that we also have in Kubernetes now is that, okay, what if I want to scale up my database, my application on my database, but I don't have more resources on my worker nodes? So on Kubernetes now, what you can do is when you don't have more, let's say I need 10 gigabytes and 3 CPUs, but I don't have that available on my cluster anymore because it's all filled out with other pods. So the Kubernetes cluster can request to the cloud provider or to whatever you are running to start a new worker node. So you can dynamically also scale up and down your Kubernetes clusters as well.
Thank you very much for the answers, Dennis. It was an amazing presentation. I will definitely try to get databases running on Kubernetes. Owen, do you have anything to say?
And yes, it was a very interesting session, and running database in Kubernetes is something a lot of people really wonder about, and if it's actually going to work or not regarding persistence of data and all. And I think this really enlightened us on some of the ways to make this happen. And thank you very much for this session.
Okay, thank you for having me, guys, and yeah, see you soon. If you have any questions, feel free to ping me on Twitter, and yeah, I will share my slides soon.
All right.
See you guys. Bye bye then.
Bye.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Consider it done.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape.
Bonjour tout le monde. On est de retour avec Jérémy Gachet de SWAN Consulting qui nous parlera de Elasticsearch. Bonjour Jérémy.
Bonjour.
Comment ça va?
Et bonjour à tous ceux qui nous regardent. Ça va très bien. Ravi d'être là parmi nous. Je suis impressionné par les conférences qui m'ont précédé. C'est vraiment passionnant.
Alors, dis-nous un peu sur ta présentation aujourd'hui.
Oui, alors, donc, je vais commencer par me présenter. Moi, je suis Jérémy Gachet, je suis développeur depuis près de 15 ans maintenant, avec un profil web au départ. Et là, ça fait 5 ans que je suis consultant dans la transformation digitale pour SWAN Consulting. Je vais vous présenter aujourd'hui une technologie que j'adore. Je suis absolument fan de ce que fait Elastic avec Elasticsearch et tous les cas d'utilisation qu'on peut avoir avec Elasticsearch.
Merci beaucoup. Et tu as l'écran et tu peux commencer. Merci.
Allez, très bien. Donc pendant cette présentation, je vais commencer par vous parler un peu de SWAN Consulting. Alors pas pour vous présenter vraiment la compagnie, mais plus pour vous expliquer comment on en est arrivé à utiliser Elasticsearch. Et pourquoi c'est devenu pour nous une technologie évidente et aussi importante. Ensuite, je vais vous présenter Elastic et les différents use cases qu'on peut rencontrer et qui peuvent être utilisés, dans lesquels on peut utiliser Elastic. Donc, SWAN Consulting, c'est une société qui a 15 ans aujourd'hui, qui a été fondée à Maurice autour des technologies IRP. SWAN était intégrateur IRP et il a fondé son savoir-faire autour de la transformation digitale. Donc en passant ensuite sur le cloud avec Salesforce en 2009 et en gérant aujourd'hui des technologies diverses dans le but toujours d'améliorer la productivité de nos clients en leur proposant les meilleurs outils de gestion possibles. Avec le temps et avec la logique qu'on a aujourd'hui, on fait face à différentes structures applicatives. On a des outils on-premise, on a toujours beaucoup. On a des clients qui sont full cloud. On a de plus en plus, c'est la tendance, des clients avec des clouds hybrides, du on-premise, du cloud privé, du cloud public. Des systèmes d'information qui sont de plus en plus morcelés, de plus en plus atomisés. Et donc, on a de plus en plus de data qui est de plus en plus compliqué à centraliser, à comprendre et à utiliser efficacement. Et c'est en essayant de répondre à ces problématiques-là pour nos clients qu'on s'est naturellement retrouvé à utiliser Elastic. Et donc en 2019, l'année dernière, on est devenu partenaire d'Elastic. Donc Elastic, c'est une société qui a à peu près le même âge que Spoon, qui a pour but, dès le départ, de faire un outil de recherche et distribué. C'est vraiment l'ADN d'Elasticsearch, c'est de pouvoir fonctionner sur des grosses infrastructures. Et la société a plutôt bien réussi, puisque il y a 2 ans, quand eux aussi fêtaient leurs 15 ans, ils ont été évalués 3 milliards de dollars à leur entrée en bourse. On aimerait bien chez Spoon être évalué à 3 milliards de dollars avec le même âge, malheureusement c'est pas encore le cas. Donc concrètement, vous allez retrouver beaucoup de définitions d'Elasticsearch sur le net. En général, des choses qui tournent autour de Elasticsearch est une base de données ou un moteur de recherche JSON sur Apache Lucene. C'est vrai, mais c'est pas une définition qui me plaît, notamment parce qu'elle donne pas l'entière, elle donne pas toutes les possibilités qui existent avec Elastic. Donc aujourd'hui, pour moi, la définition que je préfère, c'est qu'Elastic est une base de données NoSQL, JSON donc, dans ce cas-là, distribuée, optimisée pour la recherche. Donc comment on va utiliser ça? La première chose, effectivement, c'est la recherche. C'est vraiment le cas de base et ce pourquoi a été fait Elasticsearch. Le but là, c'est de faire de la recherche full text. Avec toutes les problématiques qu'on peut rencontrer dans ces cas d'usage, quand on est dans une base de données classique, on va vite avoir de grosses limitations. Elasticsearch va permettre de faire ça, de le faire bien et de le faire sur des gros volumes de data. Donc que vous soyez sur un site e-commerce avec 50 produits ou que vous soyez eBay ou Netflix, Elasticsearch peut répondre à vos besoins là-dessus et fournir les meilleurs résultats à vos clients. Le but de tout ça, ça va être, quand vous êtes sur un site e-commerce ou un site d'information en ligne, n'importe quel outil destiné au public, ça va être d'augmenter votre ROI. Meilleure recherche, les clients trouvent l'information qu'ils cherchent sur votre site facilement. Ils vont trouver les informations liées à ce qu'ils cherchent pour enrichir leurs besoins. Ça va aussi être intéressant dans les cas de système interne d'entreprise. Un employé passe en moyenne 1 heure par jour à chercher des données dans votre Gmail, dans votre Drive, dans votre CRM, votre ERP, et toute la journée, vous allez chercher, ok, donne-moi ce document-là, attends, je te rappelle dans une demi-heure. Améliorer cette recherche augmente considérablement la productivité des salariés. C'est clairement pas ce qu'on a envie de faire, de passer 1 heure par jour à chercher. Alors, on va prendre quelques exemples avec un site web, petit site web qui utilise Elasticsearch, donc le New York Times, sur un cas classique de recherche sur un site de news. Et ça va nous permettre de voir toutes les problématiques qu'on va avoir. Donc la première chose, je vais taper et pouvoir avoir des suggestions. Ces suggestions, elles vont, ou les résultats de la recherche, ça va ignorer la casse, ça va ignorer les accents, ça va ignorer les singuliers, les féminins, les pluriels, et vous permettre de retrouver vraiment l'information et pas le mot que vous cherchez. Ça, c'est une grosse force par rapport à une base de données relationnelle classique. Pardon, on vient de faire la recherche. Je me recale. Donc, la recherche vient d'être faite et en quelques millisecondes, ok, j'ai du mal à rester sur la vidéo. En quelques millisecondes, Le New York Times nous a renvoyé les bons résultats qui nous intéressent, alors qu'on cherche quand même dans environ 10 millions d'articles. Là encore, ça peut être extrêmement compliqué à faire ça sur un système de base de données classique. La vitesse est une clé. Et on remarque aussi qu'on n'a pas les résultats par date ou par ordre alphabétique. On le voit là avec les dates octobre, mai 2019, 2008, mais on a les résultats par score, par relevant score. Et donc plus un article est pertinent par votre recherche, plus il va ressortir, hein, pas uniquement parce que c'est le plus récent. Donc, toute la puissance d'Elastic, elle est dans ces facilités qu'elle permet. Notamment de ressortir les résultats par score en utilisant l'algorithme TF-IDF, donc Term Frequency Inverse Document Frequency. Ce qui veut dire que plus un mot est couramment présent dans un titre, dans un article, dans le champ que vous recherchez, plus il va être important. Si j'ai plusieurs fois open source dans l'article, il y a des chances que cet article parle beaucoup d'open source et donc il va remonter. À l'inverse, plus le terme que vous recherchez est présent souvent dans l'ensemble de votre dataset, moins il va avoir d'importance. Si tout mon site internet part d'open source, rechercher open source ne va pas avoir d'intérêt. Donc si je recherche par contre open source database, le mot database naturellement va avoir plus de valeur que open source dans la recherche dans votre cas personnel. Et bien sûr, l'algorithme de scoring peut être modifié, peut être optimisé pour répondre le mieux possible aux besoins de vos use cases en ajoutant des poids sur des champs plutôt que d'autres, en les rendant plus importants que d'autres, en étant influencé par un nombre de commentaires ou un rating sur les articles, etc., etc. Les possibilités sont quasi infinies à ce niveau-là. La typo-tolérance, c'est vraiment quelque chose qui est indispensable aujourd'hui avec le mobile. Si vous êtes comme moi et que vous avez des très gros doigts, vous faites une faute d'orthographe par mot à peu près, au moins, quand vous faites une recherche sur votre téléphone, ça veut dire que si vous n'avez pas d'outils qui vous permettent de répondre avec des fautes d'orthographe, votre client n'aura jamais de réponse en utilisant votre outil. Et c'est vraiment pas une bonne chose. Donc naturellement, avec Elasticsearch, on va supprimer les accents, on va ignorer la casse. On va, en fonction de la langue, retirer tous les mots qui ne servent à rien, ce qu'on appelle les stop words, le, la, les pour le français, qui n'ont pas de sens au niveau de la recherche. Et on va pouvoir ignorer les singuliers, les pluriels, pour retrouver, encore une fois, vraiment le sens de ce que vous voulez et pas le mot en lui-même. L'autre partie qu'on va pouvoir faire, que vous voyez régulièrement sur les sites de news, c'est quand on fait une recherche, on va avoir la liste des catégories avec la quantité d'articles qui matchent votre requête dans cette catégorie. Ce qui correspond à une série de group by dans une base de données classique. Là, on va pouvoir le faire dans la même requête d'Elasticsearch. On va avoir nos résultats de recherche et nos agrégations, et le tout va être entièrement dynamique. de snap un article en haut de page sur une recherche donnée pour lui donner plus d'importance. Voilà, donc on a l'outil complet en 10 minutes ou une demi-heure de temps de développement et 1 heure d'attente pour indexer. Voilà, ça ouvre de nombreuses possibilités. Donc une fois qu'on a toutes nos datas dans Elasticsearch et qu'on a la possibilité de scaler un système presque à l'infini, les développeurs ont très vite eu l'idée de détourner l'utilisation de base qui est la recherche full text dans des articles pour l'utiliser dans d'autres cas d'usage. Et s'il en découle ces cas d'usage d'observabilité. Puisqu'au final, rajouter des logs dans une base de données et leur donner du sens, savoir quand on a des erreurs, loguer les erreurs, connaître son taux d'erreur, ce n'est plus ni moins que de la recherche et des agrégations sur les textes des logs. Et le fait d'être distribué, là, on va avoir toute la puissance d'Elastic, puisque sur n'importe quel petit site web, on fait déjà des gigas de données de logs par semaine. Sur eBay ou sur Netflix, on arrive à des pétaoctets par jour, et on peut gérer ça dans des clusters élastiques. On peut gérer les logs, mais on peut aussi gérer n'importe quel autre type de données. Et de plus en plus, on se sert d'Elastic comme d'un data lake. On a énormément de souplesse sur le format des données. Et ça, c'est une grosse force quand on a des données qui proviennent d'un très grand nombre de sources différentes, des développeurs qu'on ne connaît pas et qu'on ne peut pas forcément tout normer. Donc on va pouvoir comme ça renvoyer des choses directement dans Elastic et utiliser les outils fournis par Elastic ou d'autres pour aller donner du sens à ces données. Et avec ça, on peut faire de la business intelligence, faire des dashboards financiers, faire du monitoring des systèmes de votre entreprise. On peut faire vraiment énormément de choses. Donc ça se présente un peu sous cette forme. Là, on a un dashboard de monitoring où je vais monitorer mon site web, spoonelastic.com, notre site web dédié à Elasticsearch, et mon post. Et on voit ici mon post à 157% de CPU, qui souffre un peu. Les données sont en temps réel. Et on peut comme ça observer en temps réel l'ensemble du parc informatique d'une entreprise. Pour un de nos clients, on monitore tous les PC, tous les routeurs, tous les serveurs de l'entreprise sont centralisés dans Elastic, dans cette vue-là. Et les admin 6 se servent d'Elastic pour vraiment tout auditer. Voilà mon PC en temps réel. Magnifique. J'ai pas réussi à mettre du rouge, bleu, jaune, vert sur les bandes, malheureusement. Dans un cadre plus business avec des dashboards financiers, il est très simple aussi de pouvoir voir l'évolution d'un système de vente par pays ou sur une durée, de pouvoir faire des compteurs qui mettent en avant des KPI très précis. Et un des plaisirs de Kibana et d'Elastic, c'est que tout est interconnecté sur ces dashboards. Donc si je choisis un dashboard et je focus sur cette période, tout le dashboard va être refresh pour ne concerner que la période que je viens de sélectionner. C'est vraiment extrêmement puissant et extrêmement agréable à utiliser. Un autre cas d'utilisation, toujours dans l'observabilité, sur les prix de l'immobilier en France, sur 2018. On a un dashboard qui est très centré sur cette map. On est là ici en région parisienne. On va pouvoir voir le prix moyen de l'immobilier, soit en sélectionnant sur une période donnée, soit, et c'est une des grosses puissances d'Elastic aussi, avec des requêtes, des géoqueries, qui sont très très efficaces sur Elastic. C'est souvent une des raisons qui nous pousse à bouger les données dedans. Je peux voir sur jusqu'à mars 2019 les cours de l'immobilier dans la région de Boulogne-Billancourt en France. Et sur un site web, ça donne ça. Alors je vais revenir sur ce dashboard plus tard, parce que là on est entre deux use cases. Le premier use case d'observabilité, deuxième use case d'observabilité, pardon, où je vais voir l'entièreté des logs de mon site et de voir tout ce qui se passe en réel sur mon site, quel utilisateur voit quoi, quand est-ce que je me fais scanner par un moteur de recherche. Mais je vais aussi avoir des cas plus centrés sur la sécurité. Et c'est le dernier use case qui est moins connu, qui est vraiment un cas qui se développe énormément chez Elastic aujourd'hui, qui vient assez naturellement en réalité avec l'observabilité, parce qu'une fois que j'ai l'ensemble des informations de l'ensemble de mon parc informatique dans Elasticsearch, il suffit de savoir le lire pour en faire ressortir un grand nombre de choses intéressantes. Pré-paramétré. Et c'est ce qu'on voit sur mon dashboard ici. Chaque ligne est une anomalie détectée par mon machine learning qui me dit hey, attention, le comportement de cet utilisateur-là peut poser problème. Allez voir ce qui se passe. Et on voit ici que j'ai différents types d'anomalies en fonction de ce qui se passe. J'ai une erreur 500, j'ai des erreurs 400 sur des pages des URL qui sont flaguées comme étant problématiques. Et là, on voit sur mon petit site où je peine à avoir 500 utilisateurs jour, 50 utilisateurs jour, par contre, que j'ai déjà un nombre d'erreurs conséquents sur une journée. Alors sur les gros sites, c'est constant. Et donc, on a tout un tas d'automatismes qu'on va pouvoir mettre en place, notamment sur les machine learning ou sur des alertes que vous allez mettre à la main, ou quand des comportements sont anormaux, des pages sont appelées alors qu'elles ne devraient pas, des utilisateurs d'un coup regardent beaucoup trop de pages. Si un utilisateur a l'habitude de regarder une page par jour et que d'un coup il en regarde 1500, c'est qu'il y a un problème. On va pouvoir envoyer des mails automatiquement à un admin système ou appeler un web service pour bloquer l'utilisateur, par exemple. Vous pouvez utiliser n'importe quel antivirus, anti-spam, firewall, le plugger avec Elastic pour que Elastic directement bloque les comportements qu'il considère anormaux ou que vous avez vous-même déclarés comme anormaux. Dans Kibana, il y a une série de vues qui sont dédiées à la sécurité, notamment les vues SIEM. Je ne vais pas forcément détailler énormément aujourd'hui, mais qui vont vous permettre de voir un certain nombre de problèmes très facilement, de les identifier. Ici, sur mon serveur web, on voit toutes les tentatives de login SSH à mon serveur. Il n'y en a aucune ici qui est légit. Aucune. Je vais pouvoir, derrière, voir ce qui se passe, bloquer des utilisateurs en fonction d'un certain nombre de paramètres. Et enfin, le gros achat d'il y a 2 ans pour Elastic, pour compléter cette boucle, ça a été un acteur du marché qui s'appelle Endgame, qui est en fait un antivirus, un endpoint, qui va se plugger, donc s'installer sur les différentes machines du parc informatique de votre entreprise, et qui va venir compléter le SIEM. Donc Endgame va bloquer une attaque d'une macro d'un de nos utilisateurs qui a téléchargé un fichier Excel virusé. Il va bloquer cette alerte. Il va loguer l'anomalie dans Elasticsearch. Votre SIEM va vous envoyer une alerte et vous allez pouvoir investiguer pour voir si d'autres systèmes ont pu être infectés et avoir le même comportement. Donc c'est vraiment des solutions extrêmement puissantes. Et plus on met le doigt dedans, et plus on s'amuse, et plus on a envie d'en faire. Donc je vous invite vraiment à mettre en place un petit cluster, soit en local, soit sur le cloud. On commence à $35, on peut avoir un cluster qui nous permet déjà de faire un bon nombre de choses, à jouer avec la solution, et si vous avez le moindre besoin, à nous contacter pour vous aider à aller plus loin. Voilà pour ma présentation. Est-ce qu'on a des questions? Des choses pour moi?
Merci beaucoup pour la présentation. Est-ce qu'on a Chitesh avec nous sur l'appel?
Oh, oui, je suis toujours là.
Bonjour.
Bonjour.
Bon, c'était une super présentation. Merci beaucoup de nous avoir introduit à Elasticsearch. C'était super intéressant. Moi, je vois sur le chat YouTube. Malheureusement, pas de questions, mais c'était une super présentation. Merci beaucoup.
Ok, très bien. Et puis n'hésitez pas à nous contacter sur le site Spoon Elastic ou via l'organisation de la DevCon.
Merci beaucoup. À la prochaine.
Au revoir.
Au revoir. Hello, I'm Neil. I'm a DevOps engineer at Avengers.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
night.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto areas providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Tickle and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. Liquid Telecom, building Africa's digital future.
C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
Hi everyone, so we are back for our session with Chris Condron, event source systems expert, and we'll be talking about understanding event sourcing as a storage choice. Hello Chris, how are you doing?
Good morning, how are you doing today?
I'm doing
bright
great.
and early here on the East Coast of the United States.
Oh, what time is it there?
It's just about 7 a.m.
7 a.m. right in Mauritius. Right now it's about 3 p.m.
Yeah, this is why I chose a late slot.
It's late slot, yes, of course. How is the situation over there in the States regarding COVID-19?
Not good. But yeah,
Not
we're
good.
muddling our way through. I mean, in Massachusetts, things are going very well. Numbers are down. You know, people are doing the right things, masks and social distancing. But
Yes.
other parts of the country are not doing well.
Yeah, well, that's a very important thing is social distancing. In Mauritius right now there is no active cases, I would say, on the street, but rather imported from other countries. So we can move a bit more freely and go to the beaches. That's a bit good. So
That's awesome.
yeah. So I will leave the presentation view to you, Chris. You can start whenever you're ready.
All right, so today I'm going to be talking about event sourcing as a storage choice. A lot of times people talk about event sourcing, they talk about, is it a pattern? Is EQRS, a pattern? But that really sort of misses the point that event sourcing is about what your database is, right? And a stream database is a database designed to do event sourcing. So today I'm going to talk about traditional, relational databases. RavenDB is one of the document databases you can use. Neo4j is a graph database. And on the right, we've got the way I represent, event stores, as a stream database with a stack queue and a database sort of both together. So eventually we're going down to a choice. In your application, what do you want to use for your database to best serve your needs? What database you're going to use is a big decision in how your entire application runs, and the right database can make a huge difference in your success. So the answer is very simply that it depends. So we're going to walk through the fundamentals, and we're going to answer in this my understanding of when to use which system. So I'm going to start off with my history with storage, right? My background. In 1990s, I got started with Telecom. This was back when in the US we were first doing voice over IP, fully packetized switches, lots of distributed things. Back in the late 1900s, this is what's called a Schroeder switch, where the actual rotary dial would move these to create wires that would go across the country. 1960s, we started to get the finger switches with the National. This is one of the original number 1.5 ESS switches for the National backbone. And then as I came in, we started building out new National switches with fully packetized networks where all of the phone traffic was event sourced. Not event sourced, event driven. It was all messages. We weren't really event sourcing, it wasn't stored. The databases were still relational or mainframes, but all of the packets going back and forth and all of that data processing was all now message and event based. Then in the 2000s, I moved into large SQL databases at insurance companies, like really large, complicated relational databases. This is a diagram of one database that was used in a company that had multiple database instances. And this is the one of the core tables surrounded. You can just barely see all the various stored procedures. So this is an example of a large centralized system. This company also had mainframes. Hard to change, hard to recover. Everything comes to the central office. And then in the 2010s, about 10 years ago, I started in finance and trading. Wealth management systems, large accounts, dealing with the stock exchange. Here we've got a lot more in terms of audits and history and fast disaster recovery that we need to deal with. And in truth, it's not just about consuming all the different trades and everything off of one exchange. We actually have to deal with multiple. We've got here New York, Hong Kong, London, doing a follow the sun approach to trading. And now what we're really getting into is distributed systems. You can't have this work if everything's coming back to that one central database that we had in the insurance scenarios, where most times in insurance you're not dealing with stuff that's real time. These systems were starting to get to what we consider now cutting edge, where you've got to have strong disaster recovery, pools of services running hot, strong audit needs, failovers, the beginnings of what we're going to see today in cloud architectures. So then, 2018, I joined Event Store. Actually, this first introduction here with event sourcing and financial services, I was actually one of the first customers for Event Store there. So I want to start with understanding really what the strengths of relational storage is. We need to understand, why relational databases are the foundation that most people still use today, right? They offer both first and third normal form structures. A first normal form you see on the right, it's a broad, flat table that's really optimized for reading and fast access. And on the left, we see a set of tables that are all related with foreign keys, with a strong schema and very sparse data that give us a very fast update from an operational point of view. It gives us a, very compact, don't repeat yourself kind of approach to storing your data. And so one of the real powers of the relational database is it can deal with both this, tight form and third normal form for the operational data, and this read or, reporting data in these large flat tables that very often duplicate data. The address you see here on the right would be folded into an individual table over here in the third normal form. One of the other things that you're going to see in a relational database is a really broad set of tools. We've got stored procedures that can update tables that can fire triggers, and we have this whole process that can move us between different things. We're going to see that there's a lot of ETL tools, extract, transform, and load. We're going to see ORMs. This is going to allow us to build data warehouses and do different pushes out to different types of other relational stores in that data warehouse. And then down here on the right, one of the things that's actually very interesting about relational databases is they provide what I'm going to call magic. Because transactions, the ability for my application to create a set of changes to a whole bunch of data, and effectively the world is going to stop for any readers or writers to that database until all the transactions that I've put into the log file are written into the data file. The world stops, right? It lets my logic not have to deal with the asynchronous nature of what's really going on. The fact that I'm sending data to another machine, that things can change, that under the covers those tables are going to be updated one by one. So I don't have to deal with a whole set of complexity here when I'm using this relational database. And as long as I can have that model where I'm in a single location, a single cluster. I know there are some distributed systems that can expand that out, but I still need to be able to lock in order to update all those fine third normal form tables that we've got. And it also really allows us to bring data together. It allows us to, by its very design, have joins, have relationships, pull data together. So the key features, again, third normal form, we have a nice compact online transaction processing portion of our data. First normal form gives us a nice efficient queries because we don't have to join anything. The caller can just go look at that one large table. This is the foundation of all your reporting databases. We can have defined table schemas. We can join that data together, and we can have those transactional commits where we just sort of stop time. So with all of the power that I just talked about, got a ton of tooling, it's well proven, it's very performant for what it's doing. Why do we need NoSQL? Why do we need these other database types? Why do we need a graph database? What does that give us? You know, if you think about what it takes in order to be able to do a hierarchy, just take a standard organizational hierarchy and fold that into a single table. And you're going to find that it becomes a very, very hard problem to store that hierarchical data correctly. The joins become very complicated. The ability for the system to be able to parse that out becomes very slow. Updates become problematic. So that's one of the things. The other thing that we're going to find is that, you know, those nested hierarchies, questions about networks. If you think about what LinkedIn does, how you on Facebook, how LinkedIn gives you that list of potential connections, how I can run a query across that graph. The structure of the data inside of that relational database, while it does provide tremendous power and has all those toolings, in these cases it actually performs very, very poorly. So while I'm not going to necessarily run the entirety of my platform or my system on a graph database, although in some cases I very well may, there are other parts of the system where I'm going to really want to model those connections, those graphs. You know, how do all the roads connect in a city? How do I measure the distances to do a mapping application? Trying to model that into a relational database, you're just going to lose your mind. Another very common NoSQL database is a document database. This here is the logo, as I said before, RavenDB, one of the more popular document databases in the market. Just picked it random. And what it allows you to do is to create a series of documents where now the updates are transactional on the individual document. Some databases allow you to do multi-document transactions, but primarily the idea is that each document is a large blob of data with an independent schema. So here, what I'm going to do is I'm going to have all my data around an employee in one document, but that allows me to have a different schema for different types of employees. I might have one schema for contractors, a different schema for regular employees, and a third schema for senior management or board of director, members. I can also have entirely different types of documents in the same system, and then I can do updates on those, and some of these systems allow me to do revisions and roll back changes. So this is going to give me a very powerful system where I might want to do something like content management, where I really do want free-form data. I might have some rules about it. My system might interpret the data in there, but it's not like that rigid schema that I had back in my relational database. I don't necessarily know or have the time to do a full data model across all of my content before I can have it. I also don't need to enforce the same schema across multiple different documents. The schema is fundamentally within that one document. And then, this can also be wonderful for things like catalogs. So what if I've got, I'm running Amazon and I want to have a different catalog item that I'm going to present on the screen. So content management, catalogs, user stores, anything where I'm really going to say the schema of this item is independent. The schema and the versioning of this item is independent from other instances and other types. And I don't want to necessarily be required to find that schema up front. So now let's talk about a stream database, or an event store. In particular, a stream database is a system that provides event storage in the terms of multiple independent streams. So the writers write into an individual stream, and we can see here that I've got the stream identifiers in black, and I've got the master log positions in orange. So someone writes into stream 1, that's the first event in a common log for the whole system. And then someone writes into stream 2, right? The first event there is the second event. Then we can go back to stream 1, events 3 and 4 sequential in the first stream. And then we go down, back and forth. And this means that while we're writing individual streams, the system is storing that data as a general log for all of the different events in the system. And this allows us to keep, so unlike in the relational system where we saw that we're joining tables, here each stream is independent. We're guaranteeing an order in the stream, and we're guaranteeing a global order, and we're not going back and changing or mutating any of the previous events that we've written. We're just appending new events to that master log. We can truncate streams, we can delete streams, but we're not going to ever modify them, right? And then at the bottom here, we have a projection. And what this shows is the ability for us to create a projection, like the one I'm showing here, where suppose we want to have a projection of the first event in every stream. We can link, right, and that's what this dotted line is saying, that we're going to create a virtual stream, much like a materialized view in a relational database, of a different ordering of the events in the main log that presents a virtual stream that can be consumed by a reader. So this allows us to create a cross-cutting stream of, say, all of the creation events, like we did here, or all of the error events or closing events or migration events as their own stream to be able to process. This stream, this projected stream, can actually bring together multiple individual streams as well to allow us to create a category. For example, like all of my invoices. So I might have each stream as a single invoice, and I'll have a projection which is all. So fundamentally, the same way we saw in the relational database with the third normal form schema and then the first normal form schema, we still have that same concept here, where we're going to have event readers or event consumers and event writers. The core limitation here is that the event writers can only write into a stream, while events consumers can read from any stream or the all stream or a projection. One of the other, and generally we're going to write our events into the database in that third normal form sensibility that we saw back in the relational database. One of the themes that you're going to see me talking about here a lot is that the fundamental work of database science that we see in relational databases still applies in full to any storage system that you want to use. If you're using a graph database, you still want to think about data retention. You still want to think about schema. Same thing for a document database or a stream database. And really what's happening here is that the event store is acting much like that transaction log that we saw in the relational database, where the inputs are coming in, they're being written into that transaction log, and then a relational database, they're persisted into the table format and the log is discarded. Here, that log of changes is the database, right? We've sort of turned that database inside out and created that log as a first-class citizen. And then we have our event consumers then building whatever is needed for the applications. This is where that CQRS pattern comes in, where we're separating out the side, one side of the database for writes and another side of the database for reads. One of the benefits of this is much the way, in a relational database, that transaction log is then used to populate the relational database. Another use here is that we can use an event store as the core of a polyglot data solution. That means we can take the events from the application, record them in the event store as a primary store, and then tie that into having adapters that give us a graph or a relational store or write out to Kafka or a document store, right? Any one of these options is valid. Now, I'm not saying that if you have all these stores, you should always put an event store in front of them. If your system can run independently with a relational database and a graph database, as many do today, then this isn't required. However, if you have cross-reporting needs, if you have distributed backup and restore needs, so you have a disaster recovery where you need to know exactly where everything is and restoring all of those to the same position, we can use the position in that core log because we have global ordering and linearization of every change. We can use that position to know where we are in these other sources, and that'll allow us to restore that back to where we are. So the key features of a stream database versus other tools you might use to store events, which can be used to do some event sourcing, but aren't really stream databases. The first one I'm going to really talk about is, fine-grained streams. You want a system which allows you on those writes to have millions of streams, millions of independent sequences. You want to be able to have, for every instance of something in your system, you want to be able to have a stream. That's because in order to update it, you're going to want to read it to know what state it's in now and restore it. So having that fine-grained stream allows you to have these fine-grained operations on your data. You're not going back and replaying millions or billions of events in order to be able to create some state, populate a writer, decide on a new event, and then publish it. The next thing we're going to want is sort of a guaranteed sequential numbering. So in those streams, one of the characteristics of stream databases is providing you with sequential numbering in the stream. This is tremendously important when we're looking at doing things like distributed messaging. Knowing that if I see event 7 before I see event 6, I'm out of order, simplifies a whole number of problems we see as regular occurrences in distributed messaging. Out of order delivery, repeated delivery, missing messages. It allows you to go back and query when you miss a message stream. Also, if you add in an ability to detect staleness, that will also solve most of your distributed messaging problems. Global ordering. One of the things that really struck me when I was, dealing with reports in finance or different systems is reports often pull data from multiple different databases. And if I need to rerun or recreate a report, and those different sources are not in the same position, I'm going to get a different answer. And the business really, really doesn't like it when the same report gives them two different results. So having global ordering of all of the separate things that are occurring in the system allows me to know that if I replay logically everything, I'm always going to get the same result, no matter how many different systems are in play. Optimistic concurrency allows me to say, you know, I'm going to write to the stream, but I read it at position 10. I'm expecting to write at position 10 again. This is critical in our microservice scenarios. When I've got lots of semi-disconnected and independent operations all running, I've got a pool of services that are servicing all of my invoices, right? I might run into situations where they each pick up the same invoice and they both try and make a change. So do I lock everything and slow everything down? Or do I use an optimistic pattern where the first one will get the right in and then the second one gets an error telling me that it wasn't, something changed while it will handle that, replay and apply the change. The ability to do push notifications out of the system is also really powerful on the read side. Not forcing queries to come back and always read the system allows us to build reactive applications where the system's going to send us data out and it's going to allow us to dynamically update things when a change occurs rather than constantly pulling and putting load back on that central server. Immutable data is one of the things a lot of people have trouble with in the beginning. Some people worry that the database size is going to become enormous. In truth, I find that most well-run event stores are smaller than their counterpart relational database that has any history or audit tables. Those tend to just grow and grow and grow. Because you can have truncate streams, move data, and migrate, it is perfectly possible to have standard data retention policies, data tiering policies, and apply them to a stream database. But what immutable data does give you is the ability to understand cache eviction. Because you're not going to have to worry about, you know, is something wrong? Has something changed? You can always use that global position, which is the next item, to know if you're stale and if something has changed. But once you're at a position, you can always trust your system is there. Position and the sequential numbering, now we can do positional queries. So if I know I've processed up to event 9,000,002, I can query from that position forward to see if there's any changes. Or I can go back in time. I can go back in history and see what it looked like 300 events ago and replay that forward and maybe try something different. We're also going to want projections or stream views in order to be able to see constructed streams that now match our current view or a view of interest that is not how the data was written in its original streams. And the last one is that streams are by their nature isolated. This means that we're now more suitable for microservices than we would be in a system which joins data together by its nature. So let's get back to what we were talking about before. So if you've got a traditional application, if you can have a relatively local system, I'm not talking about, you know, has to be a single machine, but you can run a cluster, you've got a local scope. If you've got a lot of legacy investment, if you've got a strong set of team skills around relational databases and those tools, those ORM type tools, you're building into your systems, then you're really going to want to look at using a relational database. You know, if instead you're looking at a distributed system, You've got something which is by its nature, in multiple different areas. You've got different producers, different consumers. You've got to deal with how do I coordinate and roll back and recover, right? Having a single number, a vector clock, if you will, that represents the current state of your entire database is tremendously powerful. Having the ability to use all of the log distribution patterns that are well known and well used in the industry to distribute this database out to wherever it needs to go, either in a local cluster or replicated into different regions. You can do that. Then you want to consider using a stream database. If you've got microservices, you can relax every microservice has its own database to say, well, what if every microservice has its own stream, right? Or in each category of microservice has a category of stream that all work together. And you can leverage that isolation to give you very predictable results on the microservices that are producing events. And also microservices and event processing works really, really well. So you've got message and event-driven systems. If you're looking at a modern distributed system, there's no impedance mismatch between an event-sourced or stream database and those event-driven systems. So with polyglot data as well, so we can leverage that log nature of a stream database to fill out in-memory caches, relational databases, all these different things can be fed and kept up to date and managed in a reasonable way using that core event store as a source of truth. And then any place where you have audit and history requirements, this becomes worth its weight in gold. Oftentimes what I see, and I saw this in, different areas, is that while it takes a little bit of work, because you do need team skills, you need a different approach, you've got to do different data modeling, although in truth it's not that different than what you're going to do for a proper relational model. You don't have to then go build a set of audit tables, a set of history tables. The number of systems, relational systems I've seen where maybe when the database was first rolled out, audit and history were perfect. But as that schema changed and as features were pushed in and things about audit and history were never kept up. You couldn't actually recover the state of the system from the audit tables or the history tables. They could be used for some research as opposed to an event store where audit and history are the foundation of how it's built. They're first-class systems that you can't escape, you get for free. So that's really the core things that let you decide between that traditional database or a stream database as a storage choice, right? How am I going to do HA and DR? How am I going to do distributed, right? If I don't need to do those things, then I can leverage the magic, that transactional magic of a relational system that allows me to lock, everything across the board and make a change, as opposed to a stream database where you really have to sort of deal with the fact that you're going to update different streams in different orders, and that's going to give you a different fundamental log of what happened. You're not going to lock the whole system while you update stream 1 and stream 2 and stream 3, right? You will get, if you drop 3 events into stream 1, yes, they'll go all together. But you sort of have to face up front that distributed nature of the system. You have to face up front the fact that how I'm writing the data in the system is going to be very different from how I read it. But that also allows you to simplify things, right? We're not violating the single responsibility rule, right? Where it's great to have a tool that does everything, there's a cost to doing more than one thing. And here, what we're really looking at is dividing things out into different independent components where each one is simple and they can be put together in a trusted series, a chain that proves out the fundamental point. So I think I'm a little bit early, but now I'd love to have some questions.
Thank you very much, and it was a really informative session and on pointing out the different scenarios where relational database or stream database might be more useful. And Chitesh, do we have any questions?
Yes, thank you very much, Chris, for this awesome presentation. Was wondering, do you have any top use cases for StreamDB?
Right now, so I would say trading systems. I've done in medical imaging and medical science where we're doing things that are going to require government oversight and audit. So we're going for FDA approval on drugs. So hospitals are a great use case. Anything in the medical industry, legal industry, financial industry, all different flavors of that financial industry. I've also found that there's a lot of other places where people are getting a great power out of it just with that audit capability. The other big one I'm finding is it's, in my estimation, it's the optimal database for microservices, right? So if you're doing a microservice solution, you've got lots of independent services running. The nature of having independent streams works very well with that, gives you a simple way to model it, a simple way to interact with it, and then you can either drive that out into your distributed log to go into different places, or you can create a read model right there that you're going to then expose to a standard application.
Okay. To my understanding, StreamDB works great with millions of streams of data, but
Yes.
the challenge regarding that comes to the classification of data. And one part of computer science which tries to solve this problem is machine learning. Is there any way that could be implemented together?
So, so what we're doing is we're doing a stream per instance, where in a relational database, you would have a table, and then in the table you would have a row. Think of a stream in a stream database as a row in that table, right? So I would have a whole category, which is the table, and then instances, which are the streams, right? So that's the way to think about the first level of categorization of the streams. So I might have multiple different categories and then instances of that category, where each instance is its own stream. Now, intersecting that with machine learning, one of the wonderful parts about event sourcing is you get all of the data. So machine learning is all about your training and your data sets. So one of the problems with a relational or other database where you edit data in place, right? People talk about CRUD, create, update, delete, right? It's really create, delete, right? So you create a record, you delete the record, you recreate it. You're actually destroying the old record. So as I take snapshots to feed into my machine learning models from my relational database, I'm losing the full actions of the user. If I was using it to map my system, I get the full path they took through my application. And I can now feed that into my machine learning.
Thank you for that. Indeed, I myself, I am trying Kubernetes services right now, and you've mentioned it Event Store works great with microservices. Is there any resources that developers can find?
There's resources on the Event Store website, and all of the standard literature around event-driven systems will apply to this. The one caveat I would say, one of the reasons I would not recommend some of the patterns I've seen about event sourcing directly on a distributed log like Kafka, because it doesn't have some of the key features in terms of optimistic concurrency, because it'll just accept events into it. And if I have one stream that represents my bank account and I lose my bank card, and I have one event that comes in that's me locking my account, and another event coming in, which is someone drawing $1,000 from an ATM because they got my ATM card. I don't want both of those events to go in the stream. I want one to win and one to fail. So it's much better to think about, you're going to have an application with a database, and then it's going to communicate with other applications over your distributed logs, right? And a stream database can be one of those backends and has a very low impedance with the distributed log because they're very similar to each other. I can take the events from my stream database, transform them to a public event, and publish them out onto that distributed log. And now I get all my repellability, my guarantees about commits. I can run my microservices, and I can still get all the distribution I want from that distributed log, right? And then I might have another system that reads that log and then updates a different application database from that distributed log. And they play together really well.
Yes. So yeah, thank you for this very insightful presentation. I've just learned Event StreamDB myself. Neil also is from Event Store in Mauritius. He's a DevOps engineer. Neil, anything else? I believe your mic, Neil, is muted.
Oh, thank you. Sorry about that. So yes, thank you for the amazing session. I think it was an awesome introduction to stream DBs and when it needs to be used and really when not. And thank you, Chris Condron. Hope to see you in another of our conferences.
Thank you very much.
Have a good day, Chris. Ahead. Bye-bye.
Bye.
Bye-bye.
Salut, alors nous sommes de retour, cette fois-ci avec Valérie, chef de projet technique chez Extension Interactive. Bonjour Valérie.
Bonjour, ça va?
Ça va Valérie? Dans ton résumé sur le site conférence MSCC, je vis que tu es passionné de la musique. Est-ce que tu joues des instruments aussi?
Pas vraiment d'instrument, c'est plus tout ce qui est DJing, production de musique.
Ah, ça c'est
Ouais.
cool. Moi aussi, je fais des productions. C'est donc quel software tu utilises?
FL Studio.
FL. Ah ouais, ouais. Moi, j'ai joué un peu avec FL et maintenant je suis passé à Ableton. C'est plus
Ok,
pratique, c'est pour les paresseux.
ok. Ah
Ouais.
ouais, ouais. Moi c'est plus, on va dire, pas passion. Enfin, là pour le moment, j'ai pas trop le temps, mais bon, c'est pas très souvent, on va dire.
Ah, très souvent. Tu es sur SoundCloud?
Enfin, j'avais un compte avant, mais là, le compte est plus du tout à jour. J'ai même plus les codes d'accès pour rentrer sur le compte.
Ah, d'accord, d'accord, d'accord. C'est bien évident. Donc, aujourd'hui, tu vas nous parler de quoi?
Donc aujourd'hui, je vais parler un petit peu de tout ce qui est CI, CD, plus précisément avec GitLab et comment éventuellement mettre tout ça en place sur des projets Drupal ou Symfony. Voilà.
Ah, ça paraît intéressant, donc je te laisse la place. Tu peux
Ok,
commencer ton présentation.
ok,
À toi,
cool.
bonne chance.
Merci. Donc, bonjour à tous. Donc, je suis Valérie, chef de projet technique chez Extension Interactive. Et voilà, aujourd'hui, je vais vous parler de la partie CI et CD, plus précisément avec GitLab, pour tout ce qui est projet Drupal ou Symfony. Donc, j'ai, on va dire, une dizaine d'années d'expérience en tout ce qui est développement PHP. J'ai fait un petit peu d'HTML, CSS à mes débuts, mais par la suite, je me suis tourné vers du développement back pur. Et voilà, je suis passionné par tous les frameworks, dont Symfony, Laravel, principalement. Et voilà, on va essayer de voir ça ensemble, voir comment on peut, on va dire, démystifier un petit peu la partie CI/CD et voir comment ça peut vous aider au quotidien et pour vos projets. Donc, pour commencer, on va essayer de déjà comprendre ce qu'est justement CI/CD. Donc, CI, c'est en l'anglais pour Continuous Integration. Donc, en français, c'est l'intégration continue. Donc, de quoi parle-t-on concrètement? Donc, c'est déjà un process automatisé et consistant. Donc, quand on dit automatisé, donc voilà, c'est vraiment lancé par des process. Et consistant, ça veut dire que c'est quelque chose qu'on peut reproduire et qui garde, on va dire, son état, qui ne change pas à chaque fois. Donc, ça nous permet déjà de livrer du code plus souvent. Donc, ce qui est une bonne chose, surtout quand on parle de tout ce qui est méthodologie agile. Donc, on est tout le temps dans le développement et on livre plus souvent. Donc, ça permet de tester chaque livraison de code. Donc, là, on parle plus de chaque commit, plus précisément. Ça permet de prévenir un petit peu tout ce qui est risque de régression. Donc, on va voir ça un petit peu plus tard, comment on peut mettre en place des tests, etc. Ensuite, ça va nous permettre aussi de prévenir les failles de sécurité. Donc, on sait que dans le monde du web, il y a tout le temps des petits malins qui vont essayer d'avoir accès à votre projet. Donc, ça va nous permettre de mettre en place des tests pour prévenir tout ça. On sait que voilà, c'est impossible de prévenir tous les risques, mais au moins, on peut prévenir les risques majeurs et patcher, on va dire, rapidement. Ensuite, la deuxième partie, donc c'est la partie CD, donc en anglais c'est Continuous Deployment ou Continuous Delivery, donc c'est la livraison et le déploiement continu. Donc c'est on va dire dans la continuité de la partie CI. Donc on est toujours sur un processus automatisé et consistant, donc idem. Ça va nous permettre de déployer plus souvent. Donc pour le CI, c'est la livraison de code Donc, le code est quelque part, mais n'est pas encore déployé. Là, dans la partie déploiement continu, on va déployer ce code. Donc, ça va nous permettre de déployer notre code plus souvent sur un serveur, par exemple. Ça va nous permettre justement de déployer vers des environnements spécifiques. Donc, quand on parle d'environnements spécifiques, c'est par exemple, on a la production, on a un environnement de recettes, un environnement de pré-prod, par exemple. Donc, ça va nous permettre justement de déployer des codes spécifiques vers des environnements spécifiques. Ça va nous permettre de lancer des procédures pré- et post-déploiement, donc tout ce qui est script avant le déploiement, script après le déploiement. On peut imaginer par exemple lancer un script qui va envoyer un message sur un channel Slack avant le déploiement pour prévenir vos équipes qu'il y a un déploiement qui est prévu. Et quand on parle de post-déploiement, c'est voilà, envoyer toujours peut-être un message sur le Slack pour dire que voilà, le déploiement est terminé, que vous pouvez commencer vos tests, etc. Ensuite, ce qui est important aussi, c'est que ça va nous permettre d'éliminer, voire du moins de réduire un petit peu tout ce qui est risque lié à l'erreur humaine. On sait que, voilà, on a tous fait tout ce qui est upload de fichiers par FTP. C'est pratique, ça fonctionne, je ne dis pas le contraire, mais je pense que c'est arrivé à pas mal de monde ou d'uploader le mauvais fichier ou d'écraser un fichier qu'il ne fallait pas écraser. Donc, ça, c'est quelque chose qui arrive fréquemment. Donc, tout ce qui est le déploiement continu, automatisé, va nous permettre justement de réduire ces risques. Donc, quand on parle de CI/CD, ça rejoint, on va dire, tout ce qui est philosophie DevOps. Donc, c'est un mot, on va dire, c'est un peu un buzzword qui englobe pas mal de choses. Donc, quand on parle de DevOps, DevOps, c'est produire et livrer du code plus rapidement tout en assurant la fiabilité et la sécurité du site ou de l'application. Donc, la partie CI/CD va justement nous permettre d'arriver à cet objectif-là, donc de produire et livrer du code plus rapidement, donc on l'a vu, tout en assurant la fiabilité et la sécurité du site. Donc, pour assurer la fiabilité et la sécurité, il y aura des tests automatiques qui vont être effectués à chaque déploiement. Il y aura des tests qui vont être effectués justement au niveau des commits. Et s'il y a un test qui échoue, ça va tout de suite interrompre le déploiement. Donc voilà. Ensuite, voilà le petit dessin qui va avec. Je pense que tout le monde a déjà vu, on va dire, cette petite illustration. Donc c'est quelque chose qu'on voit beaucoup depuis un certain temps. Donc tout ce qui est DevOps. Voilà. Donc, CI/CD. Comment on va dire, envisager la mise en place de l'intégration continue et du déploiement continu pour un projet. Donc, pour commencer, je sais que plusieurs d'entre vous le savent déjà, mais il faut bien sûr commencer par versionner votre code. Donc, je sais que de nos jours, c'est assez répandu, c'est devenu, on va dire, la norme. Mais je sais aussi qu'il y a pas mal de personnes qui sont encore on va dire, à avoir une copie, donc un fichier zip avec nom du projet, underscore, version 1, version 2, etc. Et voilà. Déjà, pour mettre en place tout ce qui est CI/CD, il faudra impérativement versionner votre code, de préférence avec Git. Donc, quand on parle de GitLab, c'est un logiciel qui est basé sur Git. Donc, il faudra définitivement versionner votre code. Donc, juste pour, on va dire que ce sera plus un refresher, donc pour revoir les avantages de versionner son code sous Git. Donc, ça va nous permettre de mettre en place des branches. Donc, travailler avec des branches, ça signifie que voilà, on peut isoler une partie du code et, par exemple, développer une feature, développer quelque chose sur une branche spécifique sans risquer de toucher au travail des autres ou toucher au code qui est en production ou en pré-production. Donc, ça, c'est un des gros avantages de Git. Et ça va nous permettre de conserver l'historique des modifications, donc d'avoir un suivi de tout ce qui a été fait au niveau de chaque branche. Donc, je sais que c'est quelque chose dont vous êtes probablement conscient, mais je pense que c'est toujours bon de repasser dessus, justement pour voir ce que ça apporte vraiment à votre travail et comment ça va nous aider plus tard, justement, pour la partie CI/CD. Ensuite, ça permet de collaborer, ce qui est, on va dire, le minimum quand on est en équipe. Donc, le principe justement de travailler en équipe, c'est de pouvoir collaborer sur un projet, collaborer sur du code et travailler en commun. Et voilà, le plus important dans le cadre justement de cette session, c'est ça va nous permettre de mettre en place un processus CI/CD. Donc, ça va être déterminant pour la suite. Donc, déjà, ça va de pair avec l'utilisation de Git. Donc, lorsqu'on parle de mise en place de CI/CD, il faut vraiment oublier tout ce qui est modification manuelle. Donc, on se log sur le serveur, on modifie un fichier vite fait, bien fait pour juste histoire que ça fonctionne. Non, on arrête de faire ça lorsqu'on parle CI/CD. Ça doit être fait manuellement. Donc, on va voir justement après pourquoi il faut éviter de toucher au code manuellement. Donc, les risques. Donc, premièrement, ce qui n'est pas forcément dramatique, mais qui peut l'être éventuellement, on perd l'historique. Donc, quand on va sur le serveur ou quand on va par FTP, on va aller modifier quelque chose, on va aller modifier un fichier, on perd toute l'historique. Bien sûr, vous allez me dire, on peut garder une copie du fichier, par exemple, quelque part sur le serveur, etc. Mais il y a toujours le risque d'oublier de le faire. Il y a toujours le risque que votre collègue ne comprenne pas trop ce que vous avez essayé de faire. Voilà, il n'y a pas d'historique. Ça crée des conflits lors des prochains déploiements. Là je parle spécifiquement dans le cas où on a déjà mis en place du CI et du CD sur un projet et que vous allez passer au niveau du serveur et modifier quelque chose. Définitivement, ça va faire des conflits parce qu'il y aura des modifications qui n'ont pas été gérées par Git. Mais même dans le cas où vous n'avez pas encore mis en place de CI et de CD, modifier des choses directement sur le serveur peut créer des conflits parce que votre collègue n'a peut-être pas le fichier que vous avez modifié et définitivement ça crée des conflits. Ensuite, quand on parle de modification du fichier sur le serveur, on perd tous les avantages. Non, pas de test, pas de contrôle-qualité au niveau du fichier. Voilà. On zappe tout ça, vu que voilà, le fichier est modifié directement sur le serveur. Il y a quand même des petites exceptions. Donc, quand on parle d'exception, il y a des cas où on est obligé, où on peut transgresser à cette règle et modifier des fichiers sur le serveur. Excusez-moi. Tout ce qui est fichier de configuration, de paramétrage, il faudra définitivement le faire sur le serveur. Bien sûr, il y a des façons de contourner cette partie-là et de le faire automatiquement aussi ou de le faire avec des releases, etc. Mais dans le cadre de cette session-là, on va laisser passer cette partie-là et on va justement garder ça comme exception. On peut aller sur le serveur et modifier une configuration qui est propre à cet environnement-là. Quand je parle de configuration de paramétrage, c'est tout ce qui est, on va dire, accès à la base de données, par exemple, accès à un service spécifique qui est propre à cet environnement. Et bien sûr, là, on parle de fichiers qui sont non versionnés. Donc, quand on va aller modifier quelque chose sur le serveur, c'est un fichier qui, de toute manière, n'est pas versionné sous Git. Donc, de toute manière, il n'y aura pas de conflit, il n'y aura pas de... Personne ne va faire de commit au niveau de ce fichier-là, vu que c'est un fichier qui n'est pas sous Git. Donc, Git ne sait pas que ce fichier-là existe. là, on va parler un petit peu des outils qui vont nous permettre de gérer toute la partie CI/CD. Donc, il y a plusieurs outils qui existent. Chaque outil possède ses avantages, peut-être ses inconvénients. Il y a des outils gratuits, des outils open source, des outils payants, des outils moins chers, plus chers. Mais aujourd'hui, dans le cadre de cette session, on va se focaliser plus sur GitLab. Déjà parce que enfin moi personnellement, c'est un outil que j'utilise au quotidien, voilà, que j'ai appris à maîtriser, on va dire, pour essayer d'en tirer le maximum, essayer d'en tirer le maximum pour les projets sur lesquels je travaille. Donc, petit disclaimer, je travaille pas chez GitLab, je sais pas, c'est pas pour faire de la pub pour GitLab, mais juste, encore une fois, c'est un outil qui comporte pas mal d'avantages et que j'utilise au quotidien. Et je vais essayer justement de vous expliquer pourquoi j'ai choisi cet outil-là. Donc, GitLab, déjà, il est disponible en deux versions, si je peux dire. Donc, il y a le mode SaaS, donc Software as a Service. Donc, c'est le mode, on va dire, en cloud, entre guillemets, donc qui est infogéré, donc qui est proposé par GitLab. Et il y a la version self-hosted. Donc, quand on parle de self-hosted, c'est vous téléchargez le logiciel. Petite précision, donc c'est la version open source. Donc, c'est un logiciel open source que vous pourrez télécharger et installer sur un serveur, par exemple. Mais là, vous êtes, comme on dit, on your own. Donc, vous allez devoir gérer l'installation, gérer les mises à jour, gérer tout ce qui est patch de sécurité, etc. Et voilà. Mais il y a tout de même l'option, donc pour ceux qui sont à l'aise avec tout ce qui est gestion de serveur, etc. Donc, ça peut être une bonne option et ça peut aussi être intéressant pour, par exemple, les organisations qui ont des policies, on va dire, assez strictes en termes de données. Donc, ça permet justement d'avoir le contrôle au niveau de ces données. De base, GitLab propose plusieurs fonctionnalités, on va dire, sur l'outil gratuit. C'est, on va dire, des fonctionnalités qui peuvent éventuellement même être payantes sur deux outils. Donc, de base, on a accès à plein de fonctionnalités sur GitLab en mode gratuit. Donc, ça peut être intéressant, justement, pour jouer avec, que ce soit pour un projet open source, que ce soit pour un projet même professionnel. Donc, ça permet justement d'avoir un bon niveau, même en gratuit. Ensuite, ça c'est assez, on va dire, c'est un peu les goûts et les couleurs, mais enfin, il y a pas mal de personnes qui sont d'avis que voilà, GitLab propose une interface assez simple et épurée, donc on arrive à trouver ce qu'on recherche assez facilement. Voilà, tout est présenté de manière assez claire. Donc de ce côté-là, je pense qu'ils ont fait un boulot assez sympa pour justement rendre l'expérience au niveau du logiciel le plus simple possible. Et voilà, ça c'est toujours bon à savoir. Et il y a une excellente documentation donc, sur toutes les fonctionnalités présentes au niveau du logiciel. Donc vous aurez accès à pas mal de documentation. Et voilà, quand on parle de logiciel, même en mode SaaS, donc c'est toujours intéressant d'avoir accès à de la documentation pour justement pouvoir s'y retrouver assez facilement. Voilà. Et là, on va essayer de voir un petit peu concrètement comment on met en place du CI/CD avec GitLab. Donc là, on va essayer de rentrer un petit peu plus en détail au niveau de GitLab. Donc là, ce sera spécifiquement du GitLab. Voilà. Déjà, pour commencer, il est nécessaire d'avoir ce qu'on appelle une stratégie de branching. Donc, quand on parle d'une stratégie de branching, c'est d'avoir, on va dire, des process pour la gestion des branches. Donc, je m'explique. Donc, déjà, il est important d'avoir une branche pour chaque environnement. Donc, vous allez comprendre par la suite, mais pour faire simple, pour faire du CI, du CI et du CD, surtout avec l'approche que moi je vais vous présenter dans quelques instants, chaque branche est directement mappée, entre guillemets, à un environnement. Par exemple, on peut imaginer avoir une branche master qui est mappée sur la prod, une branche recette qui est mappée sur l'environnement recette de recette, ainsi de suite. Donc, d'où l'importance d'avoir une branche pour chaque environnement. On va essayer de privilégier la mise en place d'un flow, donc ce qui est justement une stratégie de branching. Donc, les plus communs, les plus connus sont Gitflow ou une déclinaison qui est GitLab Flow, qui a été développée par GitLab. Et bien sûr, ce n'est pas forcément un prérequis pour faire du CI et du CD, mais enfin, moi j'ai constaté que ça fonctionne bien justement si on met en place quelque chose de solide. Et Gitflow ou même GitLab Flow sont des stratégies assez solides qui ont été, on va dire, mis en place par plusieurs personnes et qui font leurs preuves au quotidien. Donc, ça peut être intéressant de mettre en place une de ces stratégies-là. Ensuite, donc, pour faire du CI et du CD, il est préférable, il n'est pas forcément obligatoire, mais il est préférable d'utiliser les merge requests. Donc là, ça rentre un petit peu dans tout ce qui est organisation interne, on va dire, dans les process internes de développement. Mais quand on parle de CI, CD, vu que on est dans des processus automatisés, surtout sur les branches, on va dire, assez sensibles comme la production, il peut être intéressant justement de mettre en place une politique de merge request et justement pour que chaque request soit éventuellement revu. Donc là, ça encourage tout ce qui est code review, etc. avant de procéder au merge. Donc déjà, ça permet, je pense, de rassurer ceux qui auraient des appréhensions par rapport à tout ce qui est déploiement automatisé. Donc, on peut greffer sur ce processus-là tout ce qui est code review. Quand on parle de déploiement automatisé, d'intégration continue, ça ne veut pas dire qu'on va éliminer tout ce qui est code review, tout ce qui est validation, que ce soit par les senior dev ou par les lead dev, etc. Il est toujours nécessaire d'avoir du code review, encore plus dans ce flux-là, justement parce que tout est automatisé et que c'est toujours bon d'avoir un deuxième avis par rapport à, ne serait-ce que pour juste valider quelque chose, parce que il y a, je sais pas, il y a pas forcément une faille, mais il y a quelque chose qui peut être revu au niveau du code. Donc, ça c'est totalement optionnel, mais ça peut être aussi intéressant d'utiliser tout ce qui est semantic versioning. Donc, ça permet justement d'avoir une version, mais là, on va dire que ça concerne plus une approche parallèle qui consiste à avoir ce qu'on appelle des releases pour chaque déploiement. Mais ça peut être intéressant quand même d'avoir du versioning au niveau de votre flux. Mais on va essayer de voir un petit peu plus tard comment éventuellement implémenter cette approche-là aussi. Donc, ensuite, il est important aussi de définir des objectifs. Donc, quand on parle d'objectifs, c'est par rapport à au processus CI et CD que vous souhaitez mettre en place pour un projet. Il est important de définir des objectifs pour vraiment cadrer un petit peu ces processus-là. Donc, ça peut être des objectifs qualité. Donc, là encore une fois, on rentre un petit peu dans les process internes ou de votre organisation ou de votre travail, on va dire, au quotidien. quotidien. Donc là, il faut vous, de votre côté, définir vos objectifs qualité. Ça peut être chez vous, ça peut être chez votre client. Donc, quand on parle d'objectif qualité, ça peut être, par exemple, on se dit que le code doit respecter un certain coding style, par exemple, ou tout autre type d'objectif qualité. Mais là, il faut vraiment, à ce stade, définir ces objectifs-là et les documenter éventuellement. De préférence, les documenter pour que ça soit vraiment accessible à tous. Donc, voilà. Là, on parle de qualité du code. Donc, ça peut être des standards, ça peut être des styles, donc des coding styles, coding standards, etc. Voilà. Là, on parle aussi de tout ce qui est test, donc test unitaire, test fonctionnel. Je ne vais pas rentrer dans les détails pour cette partie-là, mais voilà. Ça fait aussi partie des objectifs en termes de qualité, donc tout ce qui est écriture de tests unitaires et fonctionnels. On va aussi parler de code review. Donc, le code review fait aussi partie des objectifs qualité. Donc, lorsqu'il y aura une merge request, on se dit que, par exemple, à chaque merge request, il faut qu'il y ait un code review par un lead dev, par exemple. Et ce lead dev, lui, il a lui-même des objectifs en termes ou de qualité ou en termes ou autre. On aura aussi, en deuxième partie, donc, des objectifs en termes de sécurité. Comme je l'ai évoqué au départ, donc on est dans le monde du web, donc il y a toujours des attaques, donc il faut arriver à prévenir ces attaques et le fait de définir des objectifs en termes de sécurité, ça va nous permettre justement de prévenir ces attaques et du moins essayer de les éviter. Donc, des objectifs, donc ça peut concerner la mise en place d'audits. Donc, il y a des audits de sécurité. Donc, il y a plusieurs outils qui existent. Encore une fois, je ne vais pas rentrer dans les détails dans le cadre de cette session, mais il y a plusieurs outils qui existent justement pour effectuer des audits de sécurité. Voilà. Ensuite, la prochaine étape, c'est la préparation des environnements. Donc, quand on parle de préparation des environnements, c'est plus au niveau, on va dire, des serveurs, que ce soit des serveurs, que ce soit des environnements où les codes sont déployés, où vos projets sont déployés. Donc, déjà, on va commencer par définir les environnements. Donc, comme je l'ai évoqué encore une fois au début, votre projet peut exister sur plusieurs environnements. Là, dans cet exemple, donc il y a l'environnement recette, l'environnement pré-prod et l'environnement de production. Donc là, il s'agit de 3 environnements, mais dépendant de votre organisation, dépendant du projet, il peut y avoir uniquement 2 environnements ou il peut y en avoir plus. Donc ça, il n'y a pas de, on va dire, de formule magique, c'est plus au cas par cas. Ensuite, on va venir installer ou vérifier tous les outils dont on aura besoin pour mettre en place du déploiement et du déploiement automatique sur le serveur. Donc, déjà, pour commencer, il faudra installer Git ou du moins vérifier que vous avez la dernière version de Git sur le serveur. Donc, ça de toute manière, on ne peut pas y échapper, du moment que vos projets sont versionnés, il faudra impérativement avoir Git installé sur le serveur. Composer. Donc là, dans le cadre justement de cette session, on est plus, on va dire, axé sur Symfony, Drupal. Donc, ce sont des projets qui nécessitent justement d'avoir Composer pour l'installation. Donc, et voilà, tout autres outils qui seront nécessaires au déploiement. Donc là, on peut parler, par exemple, de tout ce qui est NPM, etc., pour la gestion des dépendances. Donc là, c'est vraiment au cas par cas par rapport à votre projet. Ensuite, pour justement pouvoir avoir accès au repo GitLab, il faudra autoriser justement le serveur au niveau de votre repo. Donc, pour permettre au serveur justement d'avoir accès à GitLab. Voilà. Donc, cette autorisation, donc ça consiste justement à ajouter la clé SSH du serveur sur votre profil GitLab. Donc, on va voir ça un petit peu, enfin juste après là, voir comment on fait ça concrètement. Mais en gros, voilà, ça consiste à rajouter la clé SSH de la machine sur votre profil GitLab. Donc, pour cela, il faudra déjà commencer par créer une clé SSH. Donc, encore une fois, je ne rentre pas dans les détails du protocole SSH, mais juste, on va dire en gros, le serveur va communiquer avec les serveurs du GitLab par SSH, par le protocole SSH. Et du coup, il faut qu'il y ait une autorisation. Donc, l'autorisation va venir justement de cette clé SSH. Donc, c'est une paire, donc la clé publique et la clé privée. Et je vais vous épargner les détails techniques sur tout ce qui est voilà, clé RSA, etc. Il y a pas mal de ressources en ligne qui vont vous expliquer tout ça beaucoup mieux que moi. Donc, on va commencer par générer une clé SSH. Donc là, on est sur le serveur. Donc, on est sur le serveur où sera déployé justement votre application, votre site. Donc, on va lancer la commande SSH qui gêne justement pour générer. Bien sûr, on va remplacer l'email dummy par votre email. Donc, l'email correspond dans ce cas à l'email que vous utilisez pour votre compte sur GitLab. Donc, si tout se passe bien, donc vous allez avoir un message qui va vous justement confirmer la création de cette clé. Et voilà, encore une fois, si tout se passe bien, donc la clé publique sera disponible dans cet exemple-là, dans le répertoire home user.ssh et sera disponible dans le fichier id_rsa.pub. Bien sûr, ce répertoire est tout à fait, on va dire, personnalisable, mais voilà, dans le cadre de cette session, on va rester, on va dire, sur tout ce qui est répertoire par défaut. Donc là, ce qu'on va faire, on va aller récupérer cette clé publique. Donc, si vous avez l'impression que ça va un peu vite, ne vous en faites pas. Par la suite, je vais passer sur une partie, on va dire, un peu plus pratique pour vous montrer tout ça concrètement, mais là, juste pour que vous ayez une idée du process. Donc, voilà. Ensuite, on va se rendre dans les paramètres du profil sur GitLab. Donc, je vais vous montrer tout ça concrètement après, mais c'est justement ici qu'il faudra venir rentrer cette clé publique que vous aurez créée dans l'étape précédente. Donc, on va rentrer cette clé publique ici. Et cette action va justement permettre à GitLab d'autoriser justement votre serveur à se connecter à votre ou à vos dépôts Git qui sont associés à ce compte, à votre compte. Donc, ensuite, on retourne sur le serveur. Donc là, on va vérifier que la connexion est faite. Donc, on va vérifier que votre serveur arrive bien à se connecter à GitLab et si justement le serveur est bien autorisé à accéder à vos dépôts Git. Donc, normalement, vous aurez un message justement vous indiquant que la connexion est faite. Donc, voilà, vous aurez le petit message Welcome to GitLab. Et voilà, ensuite. Ok, donc là, par la suite, ce qu'on va faire, on va cloner, vu que maintenant on a accès au dépôt GitLab depuis le serveur, donc on peut cloner le projet. Donc on va se rendre dans le répertoire du site, donc c'est là que le projet sera déployé. Donc c'est le répertoire on va dire final de l'environnement. Et là on va venir cloner la branche. Donc comme vous le voyez, donc là, dans cet exemple, on est en train de cloner la branche master. Donc, et dans cet exemple, en fait, master correspond à la branche qui est mappée sur cet environnement. Donc, par exemple, si on était sur l'environnement de recette, par exemple, ça aurait pu être la branche recette ou toute autre branche. Mais là, c'est juste qu'on est en train de mapper une branche à un environnement spécifique. Donc là, si tout se passe bien, donc normalement, tout devrait bien se passer et vous devriez pouvoir cloner le projet sur l'environnement. Et voilà, à partir de là, c'est l'installation. Donc, vous pouvez lancer ou l'installation de Drupal ou de Symfony. Donc, dépendant de ce que vous êtes en train d'installer. Donc, ce sera probablement tout ce qui est composer install, installation d'assets avec NPM par exemple. Donc là, c'est vraiment propre au projet, mais c'est le moment de lancer tout ça et on va dire de faire fonctionner l'environnement. Donc à la fin de cette étape, vous devriez pouvoir accéder au site en fait, que ce soit un site Drupal ou Symfony. C'est à ce moment qu'il faudra installer et faire tout ce qui est paramétrage, etc. Comme on a vu au départ, donc et il se peut que, enfin, il est fort probable qu'à cette étape, qu'il y ait des choses à modifier manuellement. Donc, comme on l'a vu au départ, c'est tout à fait possible de modifier tant qu'il s'agit de fichiers de configuration. Donc, typiquement, pour un projet Symfony, par exemple, vous aurez le fichier .env qui devra définitivement être modifié pour l'environnement. Et là, c'est tout à fait possible de modifier ce fichier sans pour autant causer des soucis au niveau du déploiement. Vu que ce fichier, le fichier .env, n'est normalement pas versionné. Je dis normalement parce que j'ai vu pas mal de cas où justement il y avait ce fichier qui était versionné. Donc on ne va pas rentrer on va pas se dévier du sujet. Ok. Et à cette étape, vous pouvez aussi faire tout ce qui est migration de base de données, donc connexion à la base de données, import de base de données, etc. Donc, comme je vous ai dit, à cette étape, le but, c'est de faire fonctionner le site sur cet environnement, donc pour être sûr que tout fonctionne correctement. Voilà. Donc là, on va parler un petit peu de pipeline. Donc, je vais essayer de vous expliquer un petit peu ce qu'est déjà un pipeline dans l'univers CI/CD. Donc, un pipeline, en fait, à la base, c'est un ensemble de jobs, on va dire, de jobs. Dans le jargon CI/CD, un job, c'est un ensemble de processus qui sont lancés justement et qui peuvent dépendre l'un de l'autre. Donc, on va voir ça un petit peu plus en détail. Donc, déjà, un pipeline peut contenir plusieurs stages. Donc, dans GitLab, un stage, en fait, c'est une étape. On va parler de stage build, par exemple, test et deploy. Donc là on est sur 3 stages différents. On va dire que c'est des étapes qui vont mener vers le déploiement. Donc, dans le pipeline, tous les jobs d'un stage doivent réussir pour passer au prochain stage. Par exemple, pour être un petit peu plus clair, par exemple, si on est à l'étape build et que la prochaine étape est test. Si dans mon étape build, j'ai plusieurs scripts, par exemple, qui sont lancés pour justement build l'application, et que parmi ces scripts, il y en a un qui échoue par exemple, le pipeline va échouer. Donc, il ne va pas passer à la prochaine étape qui est test. Donc, ça va tout simplement échouer. Et ce qui est en soi une bonne chose et qui fait justement fonctionner tout ce qui est CI/CD. On va voir ça justement par la suite, lorsqu'on va passer à l'étape pratique, on va voir comment ça peut être bénéfique dans un processus, on va dire, de développement. Et quand on parle de GitLab, là on est spécifiquement sur du GitLab. Donc toutes ces configurations de pipeline, donc ça va se faire dans un fichier .gitlab-ci.yml. Donc toute la configuration se fait dans ce fichier. On va voir ce fichier en détail par la suite quand on va passer à la partie pratique. Donc, là, on a un exemple, comme je l'évoquais plus haut. Donc, un exemple de pipeline, ça peut être un pipeline qui possède, on va dire, 3 stages. Donc, le premier stage, la première étape, c'est l'étape build. On passe ensuite au test pour finir avec deploy, donc le déploiement. Voilà, un petit aperçu du fichier GitLab CI. C'est un fichier YML, donc pour ceux qui ne connaissent pas le YML, donc c'est un format de fichier, on va dire, qui existe depuis un bon moment, mais qui a été, on va dire, entre guillemets, vulgarisé plus par Symfony. Donc, c'est un format de fichier qui est pas mal utilisé maintenant pour tout ce qui est configuration, tout ce qui est fichier de configuration, plus précisément. Donc, le fichier GitLab CI, il est placé à la racine de votre projet. Donc, si le fichier est placé dans un sous-répertoire, etc., GitLab va pas retrouver ce fichier-là. Donc, pour que GitLab prenne en compte ce fichier, il faut qu'il soit placé à la racine du projet. Ensuite, là, on va rentrer un petit peu plus dans le fonctionnement du service CI/CD de GitLab et plus généralement dans tout ce qui est CI/CD. Quand on parle de CI/CD, on a justement parlé d'un processus, au début on a parlé d'un processus automatisé. Et quand on parle de processus, il faut bien que ce processus soit géré par une machine ou par un process. Donc, dans le cas de GitLab, GitLab supporte justement des images Docker pour lancer les jobs. Donc, et justement, le fichier GitLab CI possède un paramètre image qui permet de définir une image Docker, en fait. Une image Docker qui va être utilisée pour toutes les étapes. Et ce qui est intéressant, c'est que là, dans ce cas, on a une image qui est utilisée globalement pour toutes les étapes et pour tous les jobs, on va dire. Mais on peut aussi aller plus loin et avoir une image pour chaque job. Par exemple, si pour la partie build, on a besoin d'une image spécifique, par exemple avec PHP, etc., on peut utiliser une image spécifique. Si pour la partie test, on veut une image, on va dire, un peu plus light, où on n'a pas besoin de certains features ou de certaines choses, on peut utiliser une autre image Docker plus légère. Et voilà, ça c'est vraiment au cas par cas, mais c'est toujours bon d'avoir cette flexibilité-là, de pouvoir sélectionner une image appropriée par rapport aux besoins et par rapport au job qu'il faudra effectuer. Ensuite, donc, j'avais parlé des jobs. Donc, dans cet exemple, en fait, un job, c'est par exemple le job build. Donc, build, c'est le job qui sera responsable justement de gérer toute la partie build de l'application, donc installer, composer, etc. Donc, les jobs sont groupés dans les stages. ou dans les étapes du projet. Par exemple, l'étape build peut avoir un ou plusieurs jobs. Donc, il n'y a pas vraiment de limite. Mais c'est vraiment, encore une fois, c'est vraiment au cas par cas, ça dépend de vos besoins, ça dépend de vos objectifs qui ont été définis justement au départ, comme on a vu au départ. Donc, ça dépend vraiment des objectifs. Et on va voir justement par la suite un exemple concret pour justement voir comment on peut mettre tout ça en pratique. Donc, et ensuite, autre chose qui est important aussi à bien comprendre, c'est que dans le fichier GitLab CI, YML, donc comme on voit à l'écran, on a aussi un paramètre Stages. Donc, le paramètre Stages va d'une part nous permettre de définir les différentes étapes on va dire du processus, mais va aussi déterminer l'ordre. Donc, dans ce cas, par exemple, on a l'étape build qui va être exécutée en premier. On a par la suite l'étape test et pour finir l'étape deploy. Et le pipeline va être exécuté dans cet ordre précis. Donc c'est quelque chose d'important justement à garder en tête, et parce que justement, par exemple, l'étape test peut être dépendant du build. Et on va voir justement après comment gérer ça. Voilà. Et, encore une fois, donc, chaque job peut lancer des scripts. Et voilà, quand on parle de script, on parle aussi comme on avait vu au début, on peut lancer des scripts post-déploiement, pré-déploiement. Donc, on peut vraiment lancer des scripts vraiment poussés au niveau du fichier GitLab CI. Mais on peut aussi appeler des fichiers, des scripts, on va dire des fichiers, des scripts bash par exemple, on peut directement les appeler ici. Donc, on peut soit mettre directement la commande dans le fichier, donc comme vous le voyez à l'écran, on a plusieurs commandes qui sont lancées directement dans le fichier GitLab CI. Mais on peut aussi éventuellement appeler un fichier, un script, donc, qui est présent dans le dépôt Git. Ok, voilà, ça, autre point extrêmement important aussi, qui peut être déterminant aussi. Il est possible de limiter l'exécution d'un job sur une branche spécifique. Donc, par exemple, comme vous le voyez à l'écran, j'ai le job test qui est lancé. Mais dans ce cas, enfin, dans ce que vous voyez à l'écran, tous les jobs qui sont définis, donc tous les stages, donc build, test et deploy, seront systématiquement exécutés sur toutes les branches. Donc là, on n'est pas en train de limiter l'exécution sur une branche spécifique. Donc du moment qu'on fait un push ou un merge sur le dépôt Git, tout va être exécuté. Donc, ce qui n'est pas forcément une bonne chose. Donc, typiquement, on peut imaginer par exemple lancer des tests unitaires uniquement sur la branche développe, parce que normalement sur la branche master, donc qui peut normalement correspondre à votre environnement de prod, vous n'êtes pas supposé pousser du code directement dessus. Donc normalement, tout ce qui a été merge sur la branche master doit normalement être testé. Donc, il n'est pas nécessaire de lancer des tests sur la branche master. Mais, encore une fois, ça, c'est des choses qui peuvent justement être mises en place. Ça concerne plus l'organisation, ça concerne votre organisation, ça concerne le projet. Mais c'est des choses qui peuvent être, on va dire, gérées par GitLab. Donc, on sait qu'il y a l'option, on peut lancer des étapes sur une branche, des jobs sur des branches spécifiques. Et à l'inverse, ne pas lancer certains jobs sur certaines branches. Ensuite, autre, on va dire, fonctionnalité intéressante et très importante de GitLab, on peut définir tout ce qui est environment variables. Donc, ça peut être des variables personnalisées, donc on peut créer nos propres variables, mais ça peut aussi être des variables qui sont déjà proposées par GitLab. Donc, à savoir que ces variables sont disponibles durant l'exécution du pipeline. Donc, par exemple, dans ce que vous voyez à l'écran, là, j'ai défini trois exemples, trois variables, excusez-moi. Donc, j'ai une variable deploy host qui va me permettre justement de définir, de rentrer le host du serveur, ça peut être l'adresse IP ou le host. J'ai le private key. Donc, par la suite, on va voir à quoi ça sert exactement. Et j'ai défini une troisième variable qui est deploy user. Donc, ces variables sont disponibles durant l'exécution du pipeline. Et on pourra manipuler, enfin, du moins, lire ces variables dans le script ou dans les commandes qu'on va lancer dans le fichier GitLab CI. Donc, ça peut être vraiment très, très pratique et déterminant pour le déploiement. Et ce qui est intéressant aussi, c'est que, comme vous le voyez à l'écran, ces variables, on peut les masquer en fait. Enfin, GitLab les masque. Et ça peut être vraiment bénéfique dans le cas où voilà, on va rentrer des informations sensibles, et, par exemple des informations de connexion au serveur, des usernames, des passwords, etc. Et dans ce cas, GitLab ne va pas afficher ces données, que ce soit dans les logs, que ce soit ici dans les paramètres. Donc, on est sûr que c'est des informations qui vont rester masquées. Et voilà, ça peut être vraiment un plus quand on a des informations sensibles et qui sont susceptibles justement de causer des soucis éventuellement. Voilà, comme je l'ai précisé plus tôt, donc GitLab propose aussi des variables, on va dire, d'environnement par défaut. Donc, ça, c'est GitLab qui les propose. Et il y en a certaines qui peuvent vraiment être utiles et qui peuvent nous aider justement à créer des process, on va dire, plus poussés. Et par exemple, on a accès à une variable qui s'appelle CI_commit_message. Donc, concrètement, cette variable va contenir le commit message. Donc, comme vous savez, quand on fait un commit, on est obligé justement de rentrer un message de commit et on peut avoir accès à ce message grâce à cette variable. Donc, ça peut être vraiment pratique. Par exemple, si on a un script pré-déploiement, par exemple, on peut envoyer un Slack et dire que voilà, tel commit est en cours de déploiement et on peut justement inscrire le commit message. Donc, voilà, ça permet d'aller assez loin dans tout ce qui est script, etc. Donc, on a aussi le timestamp du commit, donc ça aussi, ça peut être intéressant. On a accès au user email de l'utilisateur GitLab, donc c'est de la personne qui a effectué ou le push ou le merge. Donc ça aussi, ça peut être intéressant. Par exemple, on peut imaginer avoir un petit script qui va envoyer un email à la personne, etc. Donc voilà, il y a vraiment pas mal d'options. Voilà, il y en a plein d'autres. Et je vous invite encore une fois à éventuellement jeter un petit coup d'œil à la documentation GitLab qui va justement présenter la liste complète de ces variables. Voilà, on a pas mal parlé. Maintenant, on va essayer de voir tout ça un petit peu concrètement. C'est un projet, on va dire, que j'ai mis en place, un petit projet Symfony, et voir comment ça fonctionne concrètement. Voilà, là je suis sur mon projet Symfony. Donc c'est un projet Symfony 5 tout simple, par défaut, donc il n'y a rien d'extra. Du coup, ce que j'ai fait, j'ai rajouté le fameux fichier GitLab CI. Donc, et là, j'ai défini 3 étapes, comme on l'a vu ensemble. Donc, l'étape build, l'étape test et l'étape deploy. Donc, à l'étape build, j'ai décidé de lancer le build uniquement sur la branche développe, donc comme on l'a vu ensemble. Donc, ça a permis justement de limiter cette partie-là. Ensuite, j'ai l'étape test que j'ai également limité à la branche développe. Et dans cette étape test, je lance le script PHP Unit. Donc là, je lance un seul test, donc juste les tests unitaires. Mais si on peut imaginer avoir plusieurs tests, donc on peut avoir plusieurs scripts qui tournent pour lancer des tests. Et ici, j'indique que cette étape dépend de l'étape build. Pourquoi? Parce que il faut que toutes les dépendances composer soient installées pour que je puisse lancer le test. Donc ici, je crée l'application, j'installe les dépendances composer. Ici, je lance les tests. Ensuite, j'ai une troisième étape, l'étape deploy, où je vais vraiment là déployer mon application. Et là, je l'ai limité uniquement à la branche master. Donc, je déploie uniquement sur la branche master et je déploie tout ce qui est sur la branche master vers cet environnement. Donc, là, c'est vraiment des commandes Linux. Donc, là, j'utilise une image Docker et une image Ubuntu avec PHP 7.2. Donc, ça me permet justement de lancer des commandes Linux directement depuis le fichier GitHub CI. Donc là, ici, j'ajoute la clé SSH que j'ai définie dans les paramètres de GitLab. Donc, je vais essayer de vous montrer ça rapidement. Donc, voilà, donc ça se fait ici, dans les user settings et SSH keys. Donc ici, là j'ai connecté justement le repo GitLab à un serveur et par la suite j'ai défini, donc j'ai fait un petit projet tout simple, donc un projet sur GitLab. Et ici, on va avoir les fameuses variables d'environnement. Settings, CI/CD. Voilà, j'ai les fameuses variables d'environnement ici. Je vais expand, où je peux définir le host, le private key et le deploy user. Donc, toutes ces variables que vous voyez ici, c'est ce que j'utilise ici dans mes commandes. Donc, j'ai accès à tout ça directement dans le fichier GitLab CI. Donc, là, je ne vais pas rentrer dans les détails de tout ce qui est commande, etc. Mais là, concrètement, j'ajoute la clé SSH au runner, donc à l'image Docker. Et ensuite, je me connecte par SSH au serveur. Ensuite, je fais un git pull origin master. Donc, encore une fois, je suis sur la branche master. La branche master est marquée sur cet environnement. Donc, je fais un git pull sur cet environnement, sur cette branche plutôt. Et ici, je lance composer install. Et là, on peut vraiment aller très loin. On peut lancer plusieurs scripts. On peut vraiment lancer tout ce qu'on veut en termes de scripts. Et voilà, si on a des process spécifiques pour le déploiement, on peut les lancer ici directement sur le serveur vu qu'on est déjà connecté en SSH. Voilà, et je pense que je suis un peu accro de temps. Et je pense qu'on a fait un petit peu le tour de ce qu'il y avait. Je vais peut-être juste vous montrer concrètement, rapidement, comment ça se déroule. Donc là, par exemple, je suis sur la branche Develop. Si je fais une modification, par exemple, donc, par exemple, je rajoute un petit truc rapidement. Et donc, c'est pas très beau. Et ça va juste nous permettre de comprendre un petit peu comment ça fonctionne. Donc là, je fais un petit commit sur la branche Develop. Je vais pousser sur la branche Develop. Voilà, c'est bon. Et là, si on va sur GitLab, donc là je retourne sur GitLab, je vais sur la branche Develop. Voilà, là je vois bien mon commit et je vois qu'il y a un pipeline qui tourne. Donc, je peux aller directement sur ce pipeline. Voilà. Et on voit que le pipeline est en train de tourner et qu'il y a deux stages, comme on a vu plus tôt. Donc, il y a le premier stage build qui est en cours d'exécution. Et j'ai un deuxième stage qui va venir, une deuxième étape, test, qui va venir juste après. Donc, là, on peut cliquer dessus pour voir les détails de l'étape, pour avoir accès au log éventuellement. Donc là, on voit que le GitLab Runner a récupéré l'image de cœur que j'ai spécifié dans mon fichier GitLab CI. Et voilà, là, il a lancé le build. Donc l'étape build est complétée, donc job succeeded. Là, normalement, le pipeline va passer à la prochaine étape, qui est le test. Voilà. Le test est en cours. Voilà. Voilà, là, j'avais défini un seul test, donc un test unitaire ici, et voilà, un test one solution, job succeeded, donc là, voilà, le pipeline est complété sur la branche dev, la branche develop, voilà, succeeded, et si on veut aller plus loin, donc, comme j'ai défini une étape supplémentaire deploy uniquement sur la branche master. Donc, si je lance une merge request de develop vers master. Donc, là, je vais me la signer juste pour que vous puissiez comprendre. Donc, je mets merge request. Je valide. Voilà. Et là, normalement, on a un autre pipeline qui, cette fois-ci, est en cours d'exécution sur la branche master. Voilà. Et là, comme je l'ai défini dans mon fichier GitLab CI, et on passe directement à l'étape deploy et on zappe la partie build des tests vu que j'en ai pas besoin sur la branche master. Parce qu'on on se dit que tout ce qui est merge sur la branche master est forcément déjà testé sur la branche développe. Donc là, ça va lancer le processus pour le déploiement. Donc, voilà le petit site Symfony que j'avais mis en place. Donc, on va attendre que le déploiement soit effectué. Voilà, donc là c'est fait. On va ici dans les logs que le template a été mis à jour. Et ici, si je fais un refresh, voilà, je vois bien le petit hello que j'avais rajouté ici. Voilà, j'ai l'impression que je suis en cours de temps. Et voilà. Merci beaucoup d'avoir assisté à cette session. Et si, je ne sais pas si j'ai toujours du temps, si j'ai toujours du temps, je vous invite à me poser des questions si vous en avez. Merci beaucoup.
Merci Valérie pour cette session super détaillée sur le CI/CD. Oui, et on a visité vraiment beaucoup de topics et je suis sûr que ça va aider beaucoup de développeurs. Est-ce qu'on a des questions?
Ouais, merci Valérie pour cette session très très pratique. Effectivement, avec la complexité où nous sommes arrivés avec le cycle de développement applicatif, c'est devenu un peu essentiel que les équipes de développement prennent davantage sur les outils comme le CI/CD. Et si quelqu'un a besoin des conseils ou des avis, où est-ce qu'il peut te contacter?
Je suis pas, enfin, je suis dans l'informatique, mais je ne suis pas trop sur tout ce qui est réseaux sociaux, mais on peut me contacter par mail. Je ne sais pas si je peux laisser mon email perso.
Ouais, bien sûr.
Donc, c'est Valérie, V-A-L-E-Y, point Ambroise, A-M-B-R-O-I-S-E, @gmail.com.
D'accord, c'est noté. On va faire partager ça sur les commentaires. Et une dernière question. Avec ton expérience de cet outil, pour quelqu'un qui veut implémenter le CICD au sein de son équipe de développement, quels sont les challenges qu'il va rencontrer et ce qu'il faut absolument éviter dans l'implémentation?
Oui, donc là, définitivement, ce que j'ai présenté en session, c'est on va dire le best case scénario, mais le pire qui peut arriver, c'est surtout pour les projets qui existent déjà, surtout les gros projets. Et pour ceux qui veulent justement implémenter du CI/CD sur un projet existant, ça peut être assez challenging dans le sens où ça n'a pas été du tout pensé pour ça au départ. Et il faudra éventuellement faire pas mal de modifications, que ça soit en termes de process, éventuellement aussi par rapport au projet même, pour le rendre, entre guillemets, compatible avec du CI/CD. Mais je pense que l'effort en vaut largement la peine. Et voilà, c'est surtout ça qu'il y aura comme challenge. Et après, bien sûr, vraiment bien planifier tout ce qui est objectif de sécurité, de qualité. Et ne pas se dire que voilà, on est sur un outil automatique et qu'on va oublier tout ce qui est code review. Donc, il faut vraiment ne pas oublier l'intervention humaine, surtout pour le code review, et laisser tout ce qui peut être automatisé aux machines. Mais il faudra, on aura du travail pendant un bon moment pour tout ce qui est code review.
Ouais, ouais. On te remercie pour ton temps, pour la présentation. Et la séance tient à sa fin.
Oui. Ben, en tout cas, merci à vous, merci à tous ceux qui ont assisté à la session et ben, bonne chance pour la mise en place du CI/CD pour vos projets.
On va te contacter par mail.
Ok. Ciao.
Ciao.
And now we have reached the end of the talk for today.
Well, unfortunately, this virtual DevCon is coming to an end. We would like to thank all the wonderful speakers who took their time and to be present here to share their knowledge and experience through the MSCC platform. We would like to thank the sponsors as well to make this event possible, and most importantly to the whole team of MSCC behind this: Johan, Mary Jane, Marine, Ish, Shelly, Aditya, Girish. The list goes on and on. They have been working very hard to make this work, and I think it is now a huge relief that it has come to an end successfully. Also, my co-host Neil, who has been fantastic so far and has done an excellent job since day one. Actually, he's actually the guy behind the technical setup and also the switching back and forth between the scenes. I mostly just sat here and blabbered along the long way. If we made any mistakes, please forgive us. This is our very first time hosting anything. Neil, how did you find this DevCon, which is a new thing in Mauritius, and the experience of hosting as well?
Oh, it's definitely a step forward, and we were not prepared to be online, but we did it, and I'm sure we gathered a lot of experience from it, and maybe we will host other events online now. And right now, the closing session should be going on in Batcave, and I invite you to join that session. And thank you very much to have been part of our track today, and look to see you in our next event. Thank you. See you, and bye-bye.
Thank you guys. See you at the next event. Bye-bye.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
take the 21C skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Consider it done.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Tickle and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched a data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner. Fingers crossed. We're proud to give back to South Africa and work with partners, Africa Tickle and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
Skills is our learning platform which we've designed to help Africa students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is synthesis? Let me tell you in 100